All right. Good morning, everyone. I hope I'm audible to you. Can I get an individual response from all the online students? Is the audio clear, video clear? I need individual responses quickly. I need individual responses. Right? Okay. Right. So, right. So when I shared this post regarding the projectile motion, most of the students thought that this one is something similar to the concepts that is in physics. Yes, when it comes to physics concepts, it's not going to be different in mathematics and physics. When it comes to the projectile motion, basically the motion is going to be okay. That part, the traveling part, or else that motion is going to be the same thing as the same thing what we learned in physics. But when it comes to questions, the standard is different. So this is going to contribute for 25 marks in your short questions paper in applied mathematics paper maths part 2, part A. Most probably the second short question or the third short question or structured essay question that you will get it from projectile motion. But if you go below 2017, you will see this projectile part as an part of an essay question. So 2017, 2016, 2015, those years, this projectile motion question is not in short questions paper, but you can see the same question or the same lesson part, theory part in essay paper, not in short question, in essay paper as a part of a question. Like part A is from projectile motion, part B is from relative motion. Okay, but now from 2018, yes, okay, from 2018 onwards, all the papers that you see, projectile motion question is included in part 2, part A paper, which means plotting essay paper. Essay paper, you don't get a significant separate full projectile question. Students didn't get. Okay, maybe in your exam it might change or may not change. We don't know. Okay, if they're changing the paper structure or the order of the questions, that could happen. Okay, because the syllabus is about to change by the for 27, but sometimes for 28 syllabus might change. If they change the syllabus, the structure will change. Sometimes they might do a small change and see. Most probably it won't happen, but in case it happens, Taylor, you study this part properly. Right. So without further ado, so I'm not going to ask what you know about projectile motion. Have you completed projectile motion physics? Physics projectiles you may have done 4, 5, 6 months back maybe. Okay, right. So physics projectile motion is contributing for MCQ. Okay, this is a 25 mark short question. Okay, right. When I'm conducting the class, if my audio is not clear, if my video is not clear, please do let me know. Okay, in the middle of the session, if the network got disconnected, please do let me know. Okay, right. Now listen carefully. Let's say there's a particle like this, a particle, some particle, and we know this is the, first of all, you should understand what's a horizontal ground. Horizontal ground, basically in our case, we consider flat earth or as the plane, the horizontal plane on earth, the plane that we stand, that's the horizontal ground. Okay, perpendicular plane to that horizontal ground is called as the vertical plane. Okay, so if this is the ground, this is the horizontal ground, and you stand on this one, the vertical plane to that one is called as the, the perpendicular plane to that horizontal plane is called as the vertical plane. So most of the projectile motion questions are based, most of the projectile questions are going to define based on these two planes. So let's say there's a particle at this point. Let's take that point O. From this capital O point, I'm going to project the particle. So when I say now, if you know something about projectiles, don't try to drag those concepts here. Try to learn this one that you are learning this from scratch. Okay. So we are projecting a particle. Projecting a particle means at some angle, when the angle, we are going to throw a particle at a certain initial speed. So imagine the situation, okay? When I throw this one like this is going to go this kind of a, right? Imagine. So when I throw this one at certain angle, when I throw this one, this is going to go like this. That parabolic pathway is the path of a projectile. We say that the path of a projectile is a parabolic pathway. Okay, so the path of the projectile is the parabolic pathway. So you can see when I project this particle at a theta angle to the horizon, theta angle to the horizontal, say. At the initial velocity, let's take the initial velocity as simple u. At the initial, we say speed here. The initial velocity or speed, we better to go with velocity. At the theta angle initial velocity, we project particle. And that particle is going to slowly go like this, and it's going or it's moving freely under the gravitational acceleration or under the gravity. This particle is moving freely under the gravity. So we know practically, if we give an initial speed and project something, and continuously we are not giving any force for that to keep its movement. So practically think and tell me, if I am putting an initial speed to project it, once the particle or the object that's in your hand is released from your hand, continuously you are not going to put any force or any power to keep that motion. What happens there? Slowly, the particle is going to reduce its speed. So at some point, it's going to make its speed, okay? It's going to make its speed 0. But the thing is, can you see that, Buddha? When I project the particle, this is going to go like this. And after some point, it's going to come down again like this. Or no, it's going to come down like this. Okay. So let's randomly select a point on this pathway. So this is the maximum height it takes. After it again turns down. So let's randomly select a point on this pathway like this. You should know it's freely moving under the gravity. Okay, in the gravitational field, this particle is moving freely. Listen carefully, which means the initial velocity won't be there by this time. So let's say I'm releasing this one, I was giving an initial velocity to this particle at a theta angle to the horizontal and t equals to 0 seconds. When t equals to t seconds, we say that t equals to t seconds. I'm taking a general position to explain the general situation. Based on this, understand the concept, and actually this lesson theory part is very easy, but I'm taking time to discuss most questions. Okay, theory part is not that hard. Right. So, and when t equals to t, so let's say this has some v velocity at an alpha angle to the horizontal. Obviously, this u and this v are going to be two different values. and I can make another inference. What is it? Obviously, this V magnitude, the magnitude of V velocity at this t equals to t, when the time is t seconds, is going to be less than the magnitude of this u. Why? The particle is freely moving under the gravitational field. Okay. In this random position, this V velocity is going to be less than the u velocity. Or this the magnitude of this V is less than this magnitude of this u. So that's a general thing that you should have as a common sense. Right. So now in vectors we studied that every in vectors, and when we start a coplanar process, we notice that every vector can be divided or can be separated into two perpendicular components. So if I take the perpendicular components of this u vector, what is this component? Horizontal component, u cos theta. What is this vertical component? U sin theta. How about this one? What about the vertical horizontal component? P cos alpha. What about the vertical component? P sin alpha. But remember, do we have any impact? We'll understand that one by the equations. So can you see, at every randomly selected point, this particle is going to have a vertical component of the velocity and a horizontal component of the velocity. So that explains the situation of this motion, right? So if we are putting a velocity in horizontal direction only, we are going to move in this horizontal direction only. If we put a velocity in the vertical direction, we are going to move on the vertical direction only. But, and in the meantime, when you put a vertical velocity and a horizontal velocity, let's say, forget about the velocity, let's say force, you put a vertical force as well as a horizontal force. So you can see that force will go with the general vectors. Okay, this is a vertical vector, this is a horizontal vector. Okay, this is a horizontal vector. We know that these are two perpendicular vectors. The resultant force must go somewhere from in between them. So who is the resultant force? I will take color. Who is the resultant force or the resultant vector? Resultant vector is a vector that can do all the work that is done to get from these two vectors. No? These two vectors together, whatever that these two vectors do. The same thing can be done by this single right? This single vector. This one tries to take the particle up, this one tries to take the particle forward like this. Then this resulting vector is going to do both. So it's still while taking its upward, it's going to do this. But the thing is, okay, you can see when a particle is moving up, it's directly the gravitational acceleration. Okay, we are moving this way, gravitational acceleration downwards. Obviously, this should reduce its speed. At some point, it becomes 0. But how about this? When I put a press to this one, okay, perpendicular we have the gravitational acceleration. So this is a perpendicular to this. Remember, this perpendicular does not have any impact on this horizontal vector. So you will understand that when we use equations related to linear motion, your physics first few lessons. I mean, mechanics the first few parts, right? Linear motion equations were there, right? So taking this general situation, we are going to explain some conditions. Alright. First of all, write the topic projectiles. Okay, write the topic projectiles. Write this statement or simple paragraph quickly. Put the topic projectiles. Write this simple paragraph. It's a small paragraph. Write it. The path of a projectile. 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 The path of a projectile is a parabolic curve. Parabolic curve. Simply, we can say it's a parabola. It's a parabolic curve. It's a parabolic curve. Simply, we can call that a parabola if you want. Alright. Separately write. Separately write. When we project an object, inside the brackets write or a particle, inside the brackets write or a particle, inside the brackets write or a particle, close the brackets, or particle, at a certain angle to the horizontal, 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 put a comma, put a comma. The path of the paths of the path of the path of the projection, path of the projection is a curve. Projection के लिए path of the projectile के लिए okay? Of the projection, it should be a projectile. The path of the projectile is a curve. Is a curve. Right. Now separately write. We are going to take this general situation and explain now. Okay. Write like this. Consider, write like this, consider a particle that is projected, consider a particle that is projected, consider a particle that is projected, right like this, consider a particle that is projected with an initial speed, but actually the correct word is velocity, okay? With the initial speed, but in papers you can see the word speed. But in terms of speed in projectiles, they are referring to velocity, okay? Initial speed, simple u. Okay, write the simple u. Initial speed u. At a at an angle of alpha, okay, not this one, I will draw a new figure, at an angle of alpha to the horizontal, horizontal means the horizontal plane, the horizontal, to the horizontal, okay, to the horizontal. Let us Consider a situation. Let us consider a situation. Let us consider a situation. Situation. Generally, 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 and try to understand the generally and try to understand the try to understand the projectile motion. Motion. Right. Listen. Listen now. Draw this figure with me. There's a particle at some point, let's say capital A. Draw with me. To the horizontal at an alpha angle with u velocity and projecting a particle. At an alpha angle to the horizontal, u initial velocity, I'm projecting a particle. I will start the discussion from here. At point A, at an alpha angle with u velocity, I'm projecting a particle like this. Okay. And we know that this goes in a projectile motion like this. And it's in that spot. So when this is t equal to 0, the time measurement starts here. So I'm randomly selecting a point on this projectile motion like this when t equals to t, when the time is t. It's a random time. So why I'm generally taking a random? Because if we can do the explanation for this random time, it valid for the entire discussion throughout the entire term. So when it comes to mathematics, Hari, we don't take specific conditions and explain everything. Specific condition explains that specific condition only, a specific situation only. So always we are going to go with a general explanation. The general explanation always gives you what? The general explanation is always going to give you the general conditions, which means the entire thing generally explained. So through general one, special condition, we can specialize it later. So general situation explains the general conditions, which is the more suitable explanation. So here I am taking the general situation T equals. Right. So at this point, okay, we know the gravitational acceleration is in this direction, T. To the horizontal, at this point, let's consider the velocity as v, this angle as theta. Mark them with me. Don't take this topmost point, but that we have to win the gun. Okay. From this starting point to this randomly say v equals to p point, the vertical, so horizontal displacement taken by the particle, let's take it as x. The vertical displacement taken by the particle, let's take it as y. Do this discussion with me, yeah. The vertical displacement taken by the particle, let's take it as y. The horizontal displacement taken by the particle, let's take it as x. Arane? Right. Listen carefully, yeah. Listen. What are the components of the initial, or is vertical and horizontal components of the initial velocity. We can see the initial velocity is alpha angle to the horizontal u. We know the vertical component is going to be u sine alpha. The horizontal component is going to be u cos alpha. But this one also we can write it as v cos theta, v sine theta, like that. But for the moment, I will take the components of v velocity. Okay, components of the velocity when t equals to t. Initial velocity means when t equals to 0. Okay, when t equals to t means I'm taking the general situation or a general time. Right. So we know the velocity is theta angle to the horizontal. We are taking that as v. I'm taking the vertical and horizontal components as v2 and vertical horizontal one as v1. We can obviously write it as v cos theta, v sin theta, but I need to do a discussion based on these notations to do some proofs with you. So I'm not going to go with that v sin theta, v cos theta part. Let's go like this for the moment. When I'm doing the discussion, you will understand why I'm doing like this. I want to give a better note for you. So try to understand like this and do. Hurry. So I'm going to mark those vertical and horizontal components here as well. This is u cos alpha. This is u sin alpha. You can use a different color there. This is, I'm taking it as v1. I'll take this as v2. Okay. Quickly write this down. Finish it. Take your notes very clearly and beautifully, okay? Take your notes very clearly and beautifully. Done. Okay. Now here is a very simple discussion. Now, something that you learned in physics and some common sense mixed together. We are learning as theory part in mathematics. This lesson is not hard at all. So we'll finish the theory part quickly and we'll move on to the questions. Questions will be then I can understand you actually learn projectiles in physics. Okay. Right. Right. Listen. So we know when there are two perpendicular vectors, we'll consider this v1 and v2 vectors. This is v2 vector, this is v1 vector. I'm taking the t equals to t situation now. I'm considering the t equals to t situation. When t equals to t situation, the velocity of the particle is p to velocity of the particle is p units. It can be meters per second. Usually we measure with meters per second or kilometers per hour. Proper technical kilometers per hour is the suitable measurement like this, based on the object that we have. So let's say a particle, we have v units. Okay. And theta angle to the horizontal. Basically, if you can remember in coplanar process, I put a diagram like this. These are the two vertical components. The resultant of these two vertical components is the original velocity that we have here, right? So instead of writing like this, let's put that here. Let's take this angle as theta. Okay, that's the theta angle. We know this one I'm already defining that speed. How to calculate the direction theta? We take tan theta, no? How do you write tan theta for two perpendicular vectors? Tan theta means the direction of the resultant vector. In this case, the resultant velocity. And the direction of the resultant velocity or resultant vector of two perpendicular vectors is given by this y vector divided by the x vector. V2 divided by V1. V2 divided by V1. Below this one, put a star mark and write quickly. Write this below this one, put a star mark and write. Write this below this one, put a star mark and write. Put a star mark and write. When t equals to t, put a star mark and write. When t equals to t, 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 the particle has, the particle has, the particle has, particle has obtained, particle has obtained a horizontal displacement and a vertical displacement. Particle has obtained a horizontal displacement and a vertical displacement. Vertical displacement. By the second star point, by the second star point, at any point, at any point, at any point of the projectile motion, at any point of the projectile motion, the horizontal component of the velocity, the horizontal component of the velocity, the horizontal component of the velocity remains unchanged, remains unchanged. The horizontal velocity, the horizontal component of the velocity remains unchanged. Remains unchanged. Remains unchanged. Correct? Remains unchanged. Remains unchanged. Harne? Right. Now listen carefully. Huh? Now listen. Let's consider a situation. Have you completed until this one? Sure. Right. So now take a rough sheet. Put all behind your book. Take a rough sheet or behind your book. I want you to do a discussion. I want you to do a discussion. When t equals to t, for this vertical displacement and for the horizontal displacement, just apply the equations of linear motion. Okay, I just want you to do some discussion that comes to your mind or whatever things that you learned in physics. You will understand what's the situation of projectiles. Then after that, when I'm doing the discussion, you will understand it better. If you use 1 minute, just try to discussion in the sense I just want to develop some equations and body whatever things that you see, just do it. One person is asking, so what do you mean by feel and do it? So MathLab feel is if you don't have a feeling in mathematics, mathematics is not gonna love you. If mathematics hates you, nobody will ever love you. Right, right. So I gave you 2 star points. Put another star mark and write. Put another star point and write. Put another star point and write. When the particle reaches its maximum vertical displacement, when the particle reaches its maximum vertical displacement, when the particle reaches its maximum vertical displacement, the vertical component of the velocity, the vertical component of the velocity, the vertical component of the velocity, the vertical component of the velocity becomes zero, becomes zero, becomes zero. Right. Then listen. This is just a general discussion, just to give you an understanding on how to apply the formulas in relevant given situations. So we'll take it as the first equation we have. Listen carefully. We know that at any point, okay, at any t equals to t point. So this t equals to t means at any general point, any t equals to t point, we know the vertical component of the velocity is going to be horizontal component of the velocity is going to be constant. If constant means whatever the initial velocity is horizontal component is going to be unchanged until it reaches its end. Then it lands on the horizontal ground, the particle stops. Don't imagine that particle and it observes the what do you call last parabolic okay. It's come like this, sticker it's not going to jump again. In those situations, don't think. Particle comes like this, hits the ground, stops. Right. That's the imagination you should have at the moment. So the particle will hit here, obviously it will jump and go another motion. How do we explain that? Right? For the moment, the pandita kata Imagine you project something, it comes like this, like in cartoon sticker nothing. Right. So it's until this point, until the end of the projectile motion, the horizontal velocity of the particle remains unchanged, which means throughout the entire discussion, if you randomly select a point, a general point, why we are taking general situations to explain the taking general situations to explain the general conditions. Why we take general conditions? Because it's valid throughout the entire discussion, not specific for a particular point. So t equals to t means any randomly selected second. It can be 1 second, 2 seconds, 3 seconds after the projection, or 10 seconds after the projection. We don't know. So it can be any randomly selected time line or time point. At any randomly selected time point, the particle is having a constant or unchanged horizontal velocity component. That unchanged horizontal vertical component is going to be what? This initially, whatever the velocity we give, that is the one is going to maintain through the entire motion. So it's going to be u cos alpha. So this is the one that's going to be in every step of the way. Right. How about V2 then? The vertical component. To find the V2, I cannot say, we know V2 is changing, no? V2 changes. This vertical component of the velocity is not vertical. We are not this up here. It's continuously reducing, and when it reaches maximum, it becomes 0. And then it changes the direction and so it's increasing. It changes the direction, it's increasing. Can't be in the same direction and come down. It's the one particle, right? You are putting the velocity here, but the particle goes down. It upsets. Then obviously, if the particle goes down, then where the velocity at this point must be downwards. So since the gravitational acceleration is supporting that side, continuously it's going to gradually increase, right? So the vertical velocity component is decreasing, comes to 0, and then it's going to increase slowly, it's going to increase. So it's a change in velocity. Then we have to go to the general explanation for that. Right. So this t equals to t general situation. In this direction, I'm going to apply v equals to u plus at formula. What is this v? V means the velocity at the given time point, or the t equals to t time. What is your initial velocity of initial velocity in the same direction? That is the whatever the acceleration we have in the motion, we are doing the gravitational fields. This one should be the gravitational acceleration. What is t? Whatever the time so you know this formula, you learn this formula in physics, no? So I'm applying in what direction? I'm applying in this direction. If you want, then apply in this direction. So based on the direction that why we select the direction in coordinate forces also I told you. Then why we select the direction? We select the direction by considering all the vectors in my selected direction as positive. All the vectors in my selected direction as positive. So in this direction, when t equals to t, the velocity is v2. I want to find this v2. This is equals to, in this direction, the initial velocity is u sine alpha. U sine alpha. What is this A? The gravitational acceleration. Gravitational acceleration, whatever the acceleration is, right? So gravitational acceleration in this direction must be like, right? Gravitational acceleration works here. We are applying in this way, then it's going to be minus g. So this is my third one. Because with the time, listen carefully. With the time, listen very carefully. The angle changes. This u doesn't change. Yeah? U is the initial velocity. This angle changes. Okay, and until it reaches this point, this part is going to be minus. After reaching the maximum, this part is going to be plus. It changes, but we can define it generally this way for any time point. Let's say when t equals to 10 seconds, the particle is here. Then you can adjust the formula according to it. Don't memorize this. Don't memorize this. Remember how to apply the formula. How did you apply this? That's why you have to remember. Don't remember this formula and focus on the questions, you won't get answers. Maybe now market window and how to apply the balance to this from based on the direction. You can't make in applying the direction. When you make errors in applying the direction, huge problem for you. Okay, right. Now listen carefully. So we know V1 and V2 both. So from 1, 2, and 3, I can calculate the direction of the velocity when t equals to t. I'm doing the calculations under t equals to t time point. A general from 1, 2, and 3, when t equals to t, this is the v velocity. That one's direction is theta. I can find theta from 1 now. So tan theta is equals to, what is v2? U sine alpha minus gt. What I am doing, is this something that we have to memorize and remember? No, Bhuta. This is something that I do just to give you an understanding on how to apply the formula and how to substitute the values properly. So this is just a random example I am doing with you. In questions, you have to get the idea, you have to do it manually for each individual question divided by V1. What is V1? U cos alpha. U cos alpha. So you can calculate the theta angle from here. This is just a general discussion I'm doing with. So understand and apply the formulas properly and do it. While this is U cos alpha, while this U cos alpha remains the same because the horizontal component of the velocity does not change throughout the entire projectile motion. But the vertical component does change, so we have to go with the equation to find the value at a given certain point. So in this general discussion, this is what I get. So based on these two values, I can calculate the angle or the direction of the velocity vector at the randomly selected point t equals to t times. Okay, this is what I have done. Meaning, quickly. If you have any doubts, drop them in the chat box quickly. right? Okay. So now, if I'm considering the entire projectile motion, if I'm considering the entire complete projectile motion, what can you tell about? Now, quickly send me the answers in the chat box. Tell me, if I'm considering the entire projectile motion, what's the displacement, vertical displacement of the projectile? If I'm considering the entire projectile motion, this is common sense. Okay. What's the vertical displacement? Vertical displacement of the projectile. If I'm considering the entire project, the entire thing, zero. It's going to be zero. Why is that? Starts here, ends in the same level. Okay, it reaches maximum, again it comes here. So the displacement is basically zero. The entire projectile motion will be considered. Okay, the entire projectile motion will be considered. But when we consider t equals to t time point, there is a displacement, no? Randomly selected t time point. Entire motion, the vertical displacement is obviously zero. But randomly selected one, there is a vertical displacement, but it's a changing displacement. So for this, randomly selected t equals to t point, I'm going to calculate the vertical displacement. How to calculate? If I want to calculate the displacement, what are the formulas that's related to displacement? S equals to ut plus half at squared. Formulas mathematics put that amount half at squared. The vertical displacement when t equals to under this doing the when t equals to t going to be y in this direction. This is equals to ut. U is u sine alpha. Initial velocity, what is t? A t time point. A is gravitational acceleration in this case, so it will be minus half g t squared. Here the vertical displacement. Here the vertical displacement. How about horizontal displacement then? You can apply the same formula, no? S equals to ut plus half at squared. Now you have to notice multiple things. There are some lazy readers, lazy fellows, they don't give opposites. They think that easy necessary. It is necessary because it gives you the so what so for the laziness, don't ignore these elements. Okay. So in this direction I'm applying, if I'm applying this direction, the displacement is x. So x is equal to what is this u? U put u cos alpha t plus. In this direction, do we have any acceleration? No acceleration. So acceleration is zero. Zero entire part is zero, so no need to write this one. So this is the horizontal displacement at a random displacement. Right. Okay. Now, if we consider entire projectile motion, if we consider the entire projectile motion, we know the vertical displacement must be equals to zero. Why? It starts here, it ends at the same horizontal level. So basically the displacement, this displacement is going to be zero. But the horizontal displacement has a value. It starts here, it ends here. So Buddha, let's calculate the horizontal displacement. Horizontal displacement. Okay, I'm going to calculate that. So let's take the horizontal displacement for the entire projectile motion as capital R. I'll take it as capital R. Okay, capital R. In this direction, I'm going to apply S equals to ut plus half at square. But in this case, the t is different. Why is that? If I'm using the same motion, it's a problem. Now, this is a randomly selected point throughout the motion. So let's say the projectile motion ends when t equals to t1. This is the time you have to apply there. Okay. Try to develop the formula. Okay. Listen. Stop right. Okay. First of all, until this point, I will do the calculations for the entire motion separately. We go with a better explanation. So first of finish until this point, I will erase these parts because I need space to write down the next one. Okay, shall I raise the board? So I shared the YouTube channel link, I mean the live sessions link with you. If possible, please share with your friends, guys. If you have your mobile phones with you, on live right. So I'm going to consider the entire projectile motion, the complete one. Listen carefully. Consider entire or else the full projectile motion. So we know the vertical displacement is going to be 0, right? Vertical displacement is going to be 0. So let's apply S equals to UV plus half AT square for the vertical displacement. So let's say when T equals to T1 only, it reaches the end. Listen carefully. We know the vertical displacement is 0 because we are considering the entire projectile motion. What is U? U is the initial vertical velocity, which is U sine alpha. What is T? T is the T1 time point. No? Why? We are considering T equals to T. We are thinking that when T equals to T1, we reach the projectile motion. So I'm considering the entire projectile motion. When this one should be T1. Gravitational acceleration is in this way. So minus G. So it's going to be minus G T1 square. Okay. Right. So now take this minus half gt1 square to the other side, you get plus half gt1 squared is equal to u sine alpha t1. Obviously, this time is not going to be equal to 0, no, right? If it is 0, it's going to be the beginning of projectile motion. I'm talking about in, so it's not going to be 0. So I can divide both sides by t1. So if I divide both sides by t1, here I will get t1 remaining, here t1 is cancelled. Let's do the cross multiplication. We get 2u sine alpha divided by g. So we get the time when the projectile motion ends in this way. We have the time value. We know u. We know what is u? The initial projection velocity. What is alpha? Initial projection angle. We know these values. Gravitational acceleration is a constant. We already know that. So by substituting the values, we can calculate the total time taken to finish the projectile motion. If we know the time, then I can calculate this horizontal displacement, right? So in this direction, I'm going to apply S equals to ut plus half at squared. What is S? The horizontal displacement of the entire projectile motion. Let's take it as R. This is equals to u cos alpha t1. In this direction, we don't have any acceleration, so this part becomes 0. A is 0, so the entire part is 0. Okay? Right, now listen. R equals to u cos alpha t1. What is u? Initial velocity. Cos alpha. What is t1? We just found it. 2u sine alpha. 2u sine alpha OG. So this is going to be R equals to 2u squared sine alpha cos alpha divided by g. If you want 2 sine alpha cos alpha, you can sine 2 alpha. So u squared sine 2 alpha over g, no problem. We'll go with this. This is what we call the horizontal range of the project. Horizontal range of a projectile motion. Horizontal range. Usual notation used as R, but in exams you might get different notations. Harane, finish until this point quickly. Understand and do it. Huh? Understand and do it. That's the horizontal range of the projectile motion. So we are taking a general situation and just manipulating the equations. Huh? Right. So I have sent the tube in the group. In the group, I have sent the tube. So you can take the tube, try the first couple of questions. I'll give you 5 minutes and then I'll be starting this. Today morning only. Do the first 2 questions quickly. Do the first 2 questions. Online students, please confirm me. Are you guys clear with the things we discussed so far? Any unclear part? Any doubtful part? Any future responses? Any unclear or doubtful parts? Quickly respond me. I need individual responses. By the first couple of questions, just two basic questions are there. Two basic questions are there. Okay. Right. Okay, listen. So they say that calculate the velocity and the direction. They ask the velocity, not the horizontal component, the horizontal component of velocity. They're asking the velocity. So to calculate the velocity, directly calculate is not easy. We have to calculate the vertical component and the horizontal component. Can't stop there. You have to use those two vectors to calculate the velocity component at that point. So project direction of the part directed, sorry, velocity and direction of the particle that is projected with 200 meters per second at an angle of theta degrees to the horizontal. So I'm not going to draw the entire projectile motion. Let's discuss the initial situation. So they projected a particle with 200 meters per second at a theta degrees angle to the horizontal ground. And we know that based on these situations, we can calculate the initial horizontal velocity component going to be 200 cos 30. 200 cos 30. Cos 30 is square root of 3 over 2. Will be in meters per second, which is equal to 100 root 3 meters per second. How about the vertical velocity component? 200 sine 30. 200 sine 30 is half, which is going to be 100 meters per second. 100 meters per second. On the home, right? So we have the initial vertical velocity component and horizontal velocity component both, right? So now I hope you are familiar with how to take the horizontal component of the vector and the vertical component of the vector. One. So the first question is, after 5 seconds of the projection, after project after the projection, okay, when you project the particle, after 5 seconds, they are asking us about the velocity. So, in order to calculate the velocity, I need to understand after 5 seconds, okay, if this is the initial velocity, after 5 seconds, it will be somewhere here, randomly, let's see. Here we have a velocity. This is the velocity they are asking about. In order to calculate this one, I need the vertical component and the horizontal component both. If I need the vertical component and the horizontal component, I need to apply formulas to the vertical velocity, the horizontal velocity. They are asking nothing about the displacements. Okay. So I'm going to apply when t equals to 5 situation, 5 seconds. When the time is equals to 5 seconds. Listen carefully. Yeah? To the vertical direction, vertically upwards direction I will apply. If it is not upwards, if it is downwards, we will be considering minus. I'm going to apply V equals to U plus what? AT. What is V? Okay. What is V, Pudam? This is the velocity we have to find. So let's say when t equals to 5 seconds, the velocity of name is V5 here. Just to give an idea, after 5 seconds, you will see. Or just let's keep it as V, no problem. The vertical displacement, sorry, vertical velocity component after 5 seconds. So this is equals to what is your initial vertical velocity component, which is 100 meters per second. But when you are substituting values to the formula, or when you are substituting values here, to reduce our complexity of writing, no need to put the but then one if you put the units, that's okay. So this is going to be 100. I'm applying the formula in this direction. In this direction, gravitational acceleration is in this direction downwards. We are applying upwards. So in the formula, the downward vectors are going to be negative. So minus G. What is T? T Buddha, G you can take it as 10. Okay. In this field for the calculation, take G as 10 meters per square second. Like this, you can take the G equals to 10 meters per second. That's how we read it. So it's actually 9.8 something. So no need to use this decimal value in this one. In mathematics, usually we go with the notation G. But here, if you want the numerical value, just take 10 for making the simplifications easier. Just to make the simplifications easy, right? In mathematics, we are mainly focusing on the qualitative understanding of the calculations part. Calculation can be done by anyone. Okay, thinking is the most important one. Multiplied by, we are discussing about after 5 seconds, multiplied by 5. So the V equals to 50 meters per second. We get 50 meters per second. 100 10 times is 50, 100 minus 50 is 50 meters per second. Okay, so I'm going to calculate the horizontal component. Do we have to calculate the horizontal component? No, because horizontal component doesn't change. It's not going to change. So the horizontal component is going to be the same 150 meters per second. So I know the vertical component of the velocity at t equals to 5 or after 5 seconds of the projection, which is 50 meters per second. And we know the horizontal component already it's an unchanged value, 103 meters per second. We need to calculate the velocity component and its direction. So let's take the direction to the horizontal as theta. Let's take the direction to the horizontal as theta. So if we take like that, listen carefully. We know the result, velocity, these are vectors. How to calculate the resultant vector of two perpendicular vectors? The resultant vector, let's take it as B. I'll take it as B5 after 5 seconds. Let's take it as B5. After 5 seconds, just to give that idea, I'm using this notation. You can use any notation, as long as you depict or represent that one in the figure, the examiners know that you know the idea. If you are not showing this one in figure or clearly stating what this is, you will lose marks because the person who checking your answer don't know what is this V5. Here, clearly this picture shows that V5 means the velocity after 5 seconds, which is the answer for this question. So how to calculate the magnitude? Magnitude is equals to square root of sum of the squares of the two perpendicular vectors. 50 square plus 100 square root of 3 complete square. Answer will be in meters per second. Simplify and give me the answer quickly. 50 square plus 100 root 3 square. I'm not going to simplify. Simplify and give me the answer quickly. Simplify and give me the answer quickly. Make it quick. Five squares 25. Here we have 0. Then you square, you get double zeros, you get 2,500. 100 squares 10,000. 10,000 times 3 is 30,000. 30,000 plus 2,500 is equal to 32,500. You have looked at me? Somewhere 32,500. This is 2,500 plus 100 square is equals to 10,000. 10,000 root 3 square is 3. 10,000 times 3 is 30,000. Add them 32,500. B5 is equals to square root 32,500. This is 325 multiplied by 100. No? So if I take that 100 outside the square root, we get 10 square root of 325. This is a multiple of 25. So we can simplify it further. No? Simplify it further and give me the final answer. Answer will be in meters per second. Where? I'm not going to find it. These are easy calculations. Do it. We have 1325 parts. So square root of 25 is 5. 5 times 10 is 50. 50 root 13 is the answer. You will get the answer 50 square root of 13. This is the final answer for the magnitude of the velocity at when the time is 5 seconds after the projection. Okay, no? Right. So I need to calculate this angle because they are asking about the direction also. We know tan theta. Write it here. Tan theta is equals to how to calculate this direction of two if you have two perpendicular vectors. Vertical component divided by the horizontal component. 50 meters per second divided by 100 root 3 meters per second. Meters per second is actually acting like cancelling out. What's the reason? They are taking a ratio. Right? So 50 divided by 100 root 3. 50 divided by 100 square root of 3. This is going to be tan theta is equals to 1 over 2 square root of 3. If you want, you can convert it to a surd. You'll get root 3 over 6. But I will just keep it like this for the moment. We need the idea only. 1 over 2 square root of 3. So therefore, the required velocity is going to be to the horizontal direction at a theta angle. we have the velocity 50 square root of 3 meters per second. This theta is equal to tan inverse 1 over 2 times square root of 3. This is what they expected from you. Okay. So this clear calculation should be there in your answers also. Try to do this for after 10 seconds and after 15 seconds, right? After 15 seconds also. 10 seconds one is easy because you get the vertical component 0. This answer must be 0 if you do it for 10 seconds. Check. Okay, right? After 10 seconds, when the time is 10 seconds, I'm going to apply the same direction v equals to u plus at. You know, initial velocity component in the initial vertical velocity component is 100. We know we are applying in this direction, so the gravitational acceleration is going to be minus because it's in this direction. And t is 10. Time is after 10 seconds. So 100 minus 10 times 10, 100, it's going to be 0. So because the work is easy, you don't have to go with all these things. If the vertical component is 0, that's the only component that's remaining in velocity. Horizontal component. We already have the horizontal component. No, the horizontal component does not change throughout the projectile motion. If the horizontal component does not change throughout the entire projectile motion, the direction of the velocity after 10 seconds is going to be in this direction, in the horizontal direction, in this direction. What is it? 100 root 3 meters per second. This is the answer. Meaning you have the acne. Vertical component is 0 means only the horizontal component exists. Basically, what is this position? The maximum height. At the maximum height or the maximum displacement of the projectile motion, we get this. So there's a question in the box. If I'm giving you a question, why should I skip the parts? 10 seconds, 50 seconds, both. Okay. Right. How about the t equals to 15 seconds? We'll apply the formula in this direction. V equals to u plus at. V means the velocity, the vertical velocity component when time is t, when time is 15 seconds after the projection. So V equals to initial velocity component, vertical velocity component 100. We are applying in this direction, so the gravitational acceleration will be minus 10 times. Time is 15 seconds. So this is going to be 100 minus 150. So you will get V equals to minus 50 meters per second. So we get a vector here. In this direction, vector is minus means when the time is 15 seconds after the projection, the vector component, velocity vertical component is downwards. No? If you get a minus value upwards means the original direction, the original active vector is in downwards direction. I hope you are familiar with those words. In vector expression, I told you the active vector is in other direction. If a vector is minus, the active vector is in other direction. This is going to be 50 meters per second in downwards plus. We know. So the vertical component is 50 meters per second here. We know the horizontal component does not change. It's 100 square root of 3 meters per second. So the resultant velocity goes like this. We take this angle as alpha. I take that angle as alpha. I need to calculate this velocity component. Let's take it as V15 because after 15 seconds, just to give that idea. This V15 is calculated as square root of sum of the squares of the perpendicular vectors. If we are having two perpendicular vectors, calculating the resultant vector is easy. Here we have vertical vector component, which is velocity in this case. This is the horizontal velocity component. These are perpendicular vectors. Velocity is a vector. So when you have two perpendicular vectors, the resultant force is calculated by square root of sum of the squares of those two perpendicular vectors. We did this one in vectors. We did the same thing in our four-plane forces lesson as. Then over now these things cannot be something that you should go notes once again. You have to solve in the. So in today's class, the participation is not good. Alright? Maybe poeta still gonna give. Alright? So some lazy fellows are there, sometimes might alright? Poeta will take a holiday from the class. Right? So result is going to take a formal holiday from your life. Right. 50 square plus 100 root 3 square. Answer will be in meters per second. I think this is the same calculation as V equals time 5 seconds. Is going to be 50 square root of 13 meters per second. What's the angle? Tan alpha. How to calculate it? Vertical vector divided by the horizontal vector. 50 divided by 100 square root of 3. So this is going to be alpha equals to tan inverse 1 over 2 square root of 3. 2 square root of 3. So let's take the final answer. Final answer you have to represent in this way. This is alpha, which is tan inverse 1 over 2 square root of 3. Answer is 50 square root of 13 meters per second. Final answer represent like this. This is what they expect. You have to mention the vector value and the direction both clearly. Right. Try the second question, third question, and fourth question. 2, 3, and 4 quickly. Right, second one, third one, and fourth one. I'll give you 5 to 10 minutes. Give it a try. Right. Okay. Second question, what they say, the particle has been projected from an origin, capital O, inclined to horizontal, which means at some angle they are projecting a particle. We don't know what angle they are projecting the particle. Okay. Okay. Right. Listen. So at some angle, they are projecting a particle. Okay. At some incline means some angle. So we don't know at what angle they are projecting. Let's say it as theta. A particle has been projected from an origin. So the origin is capital O. Right. If the velocity and the direction of the particle after 5 seconds of the projection are 50 meters per second and 30 degrees respectively. So I don't know what's the initial velocity. Okay, initial velocity is so I can put it u or you can use any notation. You can use any notation. Based on this one, I can calculate, I can write down the horizontal component to the vertical component. But remember, this u is something that we introduce, which is we are able to find it if necessary. If necessary, we have to find it. Right. So we'll see. Sometimes, even though we put some notations, in some questions we don't have to find it. Okay, but in this case, we may have to find it. If necessary, obviously, you have to find it. So this is when the time measurement starts. After 5 seconds of the projection, the particle is somewhere here, we don't know. They say that the particle's velocity is 50 meters per second. Okay, I hope you all can see. 50 meters per second. Okay. At a 30 degrees angle to the horizontal ground. Only. At the 30 degrees angle to the horizontal ground. The projectile, let's say projectile is going like this. Okay. At some point when t equals to t point, so t equals to 5 seconds. Okay. This is the velocity, 50 meters per second. And the angle is 30 degrees to the horizontal ground. So this is what they say. So you should be able to clearly mention the details, but explain the question in figures. Find the projected velocity and angle. Projected velocity means this. They wanted us to find this. We know, if we know the velocity here, we can calculate the horizontal component. What is it? 50 cos 30 degrees. But so I can write when t equals to 5 seconds, horizontal velocity is equals to 50 cos 30 degrees meters per second. What is cos 30? Because square root of 3 over 2, we get 25 root 3 meters per second. Now we know it's the horizontal velocity. What does that mean? If it is the horizontal velocity, the initial projected horizontal is the same. Right? Horizontal velocity doesn't change. We can say therefore u cos theta is equal to 25 square root of 3. This is my first equation. Right. Now we'll calculate, we'll apply v equals to ut plus half sorry, v equals to u plus at in this direction. What is this? When t equals to 5 seconds, at this time I am applying all the formula. When do the calculation when it is 5 seconds. After 5 seconds, the vertical velocity component is 50 sine 30. Right? This is 50 sine 30. This is 50 sine 30. Listen. This is equals to, what is this? U sine alpha minus G, they wanted us to take it as 10, T is 5. So 50 sine 30 can go to sine 30 is half, so 50 times half, it's going to be 25. Minus 50 taking the other side becomes plus 50. This is equals to U sine alpha theta, theta, theta. This is theta. This is theta, okay? My bad. It's theta. U sine theta. So from this one we get U sine theta is equals to 75 here. This is my second equation. This is my second equation. Now let's see. Second equation and the first equation from second equation is being divided by the first equation. I'm dividing the second equation by first equation. What do we get? U sine theta divided by U cos theta. This is equals to U sine theta is 75 divided by 25 is 3. Yes, U and U cancelling out. We can cut that U is not equal to 0. If the U is 0, this projectile motion can't even because U bindu. Right? So that's common sense. So here we get tan theta is equals to divide this by 25 1, 25 3, 3 divided by root 3 is square root of 3. So theta equals to tan inverse square root of 3. Which means theta is equal to 60 degrees. Therefore, projected angle is 60 degrees. Projected angle is 60 degrees. Let's take the first equation from 1. Yes, from 1. U cos 60, theta is 60, is equals to 25 square root of 3. Cos 60 is half. This is equal to 25 square root of 3. So cross multiplication, U equals to 50 square root of 3 meters per second. Therefore, projected velocity is 50 root 3 meters per second, right? So there is nothing that we use something additional to the knowledge. Projectiles maximum. Basically, we are dealing with the linear motion equations in 2 directions, vertical direction and horizontal direction. V equals to U plus 30, S equals to U plus half A plus V square equals to U square plus 2A, and the other one. S equals to V plus U divided by 2 into T. Those are the whole equation. That fourth equation very rare to use, but other three equations are frequently used. From the for the first two equations, actually, we have used only the T equals to U plus 80 formula. But the thinking is important. They want us to consider. And this initial velocity U. So basically, they want us to find 2 unknown things. If you want to find 2 unknown things, you need how many equations? 2 equations. So that's why it's harder to find 2 equations. You have 2 equations more than enough to solve and find 2 unknowns. More than enough, that's the bare minimum requirement. We have enough evidence or enough equations to find the unknowns. So remember, if they are asking us to find something, 2 unknowns, we might need 2 equations. So to get those 2 equations from the given existing data, just manipulate it. Just manipulate them and try to. Okay. So this is still, I don't enter the standard from maths. This is still physics for standard. Physics or lecture standard. Little bit extra they might do. Okay. But combined for permanent. Exercise 1 is just dealing with some basic things. Exercise 2, okay. Right. There's a message in the chat box. So this class is free for everyone, right? So because one of my friends using the link right here. That's why I'm putting that on YouTube. No problem. You can even share the PDF file with them. Okay. Right. Clear with that online students? Any individual responses quickly? Clear with that? Understood? Any unclear part? Individual responses. Okay. Everyone respond. Otherwise, I don't know whether you guys are here or not here yet. Maybe you are hungry, but until I finish the exercises, exercise two, first two questions, I'm not going to give you a break. Right, try the third question. Try the third question. Okay. The newly joined student, you are the one who sent me the message via WhatsApp. Is that so? Okay. Right. Okay. Now what they say? Particle has been projected from an origin, capital O, with velocity 7 minus 30 j meters per second. So it's given in terms of ij vectors. So capital O is the origin point, 7 minus 30 j's, which means the horizontal component is 7 I. We have to imagine a big xy coordinates plane, and on the positive side of the x-axis we have the I unit vector, and then the positive side of the y-axis we have the j unit vector. So this is how we explain the initial velocity of the projection. So we have 30j. These are vectors. Okay, right. Particle passes through a point P divided by OP is equal to 49 plus G. And the particle will have a resultant velocity like this. Particle goes through some point P, will be given the OP vector. You see, they have given this OP vector, okay, OP vector as 14I plus YJ. This one as 14I plus YJ. Okay. So if we are considering this as the origin to the standard coordinate plane anyway, there's an issue with the question. Okay. So actually the position, not the OP position vector is given as 49 plus YJ. Okay. So this should be position vector. Right. So we mark like this. But still there is a problem with the question, but I'm not going to highlight the issue here. We'll go into a general idea. So the component is 14I here, and the vertical component is YG. Right? So particle passes through this point again, goes like this. Now what they are saying, calculate the time taken by the particle from A to P motion. Calculate the time taken by the particle from A to P motion. The time taken from this point to this point. So we'll take the vertical displacement as y, the horizontal displacement as x. Vertical displacement as y and the horizontal displacement as x. Just keep it like this because already they have given you a y. So this is t equals to t 0. When the particle reaches this point, let's say this is t equals to t. Right. Now think how we can manipulate the given linear motion expansion in this. This is the velocity vector. What is this? The position P vector. So position P, the coordinates actually they have given. This is not the vertical component. This is not the horizontal component. Yes, read carefully. AP is given by 49 plus 1 which means this position's x coordinate is 14, y coordinate is 1, which means when the name is displacement figure from the origin 14, from the origin y. Okay. From O to P, they have it. So this is from this one, this is 14, from this one, this is Y. Now try to do it. Hit another. Give it a try. You have to understand the given data, okay? They have an OP vector. OP vector means a position vector. It's not this point coordinates are given. We are not saying that the velocity of this point in IG vectors. Here, the velocity is given. Can you see the units? Okay. When the OP is given, they are saying that it's 49 plus YG. But when the initial velocity is given, after the ij component, they have mentioned ms minus 1, which is the velocity. This is not a velocity. This is just the vertical displacement, the horizontal displacement and the vertical displacement from Earth is given here. Alright? This projectiles lesson is not hard. Reading the data and getting the ultimate idea behind this is the complex part. That one, you will have to open your brain and think. This is not going to be this is which is more one of the exercise 1 to 3 categorized. Exercise 1 just to make family equations and all. And exercise 2 critical thinking. Exercise 3 is the exam standard. Okay. So if you go through the questions, you can see the first question that is the question of third question about the amount of think. Third question is another little bit difficult equation. 5, 6, 7 questions have been more complex. Right? Past of the questions are not going to be complex. It's going to be a standard ones, but complex than the exercise 1, easier than exercise 2. Okay? So there's a certain order be maintaining exercises. So properly understanding do. Now we know the vertical horizontal displacement of the particle from O to P and the vertical displacement from O to P. The motion horizontal displacement and the vertical displacement is given like this. Make a minimum mark. Okay. Sorry, my bad. We can mark like this. We can mark like this. I have marked the coordinate y like this. We can mark like the other way. It's from. It's from. Right. It's not a velocity. So I was actually trying to mark that and erase it. Then after the explanation, I forgot to erase it. Okay. So here these are vector components of the velocity vector. These are components of the displacement, horizontal displacement and the vertical displacement. So the horizontal displacement, I'm going to apply, listen carefully. What do we need to calculate? To calculate the time it takes to reach P from O under this motion. So we can easily do it by taking the horizontal component, right? Horizontal displacement. Let's apply SC equals to UT plus half is in the horizontal direction. What is the displacement from O to this point? 40. This is equals to U. What is U become? UT plus half is square. U is the initial velocity, horizontal velocity component 7. Then we have to put I. No. Why we have this 7I here? 7I that in this direction, the magnitude again. This I is given to understand the direction, okay? Whether it's vertical or horizontal. So 7 is enough to substitute. The magnitude is enough to understand and do. See, that's what we have to find. In this direction, do we have any acceleration? No. So this one becomes 0. So the time is going to be 7 divided by 7, 2 in seconds. Why is that? The velocity components are given in meters per second. Then obviously this one should be in meters, this one should be in meters per second. Here also should be in seconds. So the time taken from O to P motion is 2 seconds. 2 seconds. Now what they ask? Calculate time taken by the particle from motion motion. Find what? Now I can apply in this direction. Listen carefully. In this direction, S equals to ut plus half at is why I'm selecting this equation. That's another. You have to ask me. You have to question me why the theory of using this particular equation can't be equals to u plus at like b. No. My ultimate goal is to find this displacement, the one. So you have to select the displacement formula. So when you are using formulas, understand the reason behind it. Just like we can apply the formulas, like this was applied multiple. We have formulas, actually, there the formulas and trying something until this was the run. I'm buying there and having a not solving you, I'm just saying. So select the formula based on your purpose. The purpose is to find the displacement. The displacement formula. This is the easiest one because I know all the knowledge. You know, P know, half is constant, H know, T know. If we know these things, we can apply. What is why we know this T? So we just calculate it. S is the displacement from O to P. This is equals to U. What is U? Initial vertical velocity component, which is 30. Multiplied by T is 2 minus half times 10 times T is 2. 2 and 2 cancelling out. You get Y equals to 30 times 2 is 60. 60 minus 10, which is 50. A is 10. No? 80, half 80 squared. No, sorry, this is 4. Sorry, no, my bad. This is going to be 20. So you will get Y equals to 40. Therefore, 40 what to the meters, 40 meters. Okay, unit diameter no marks. 40 meters. Right. Calculate the velocity vector at T. Now they are asking us to calculate the velocity vector at T. So let's say the horizontal component, what's the horizontal component? Let's say it has B1 and the vertical component has B2. Right. So at point P, horizontal component of the velocity is going to be equals to what to the this one, which is 7 meters per second. How about this one? Horizontal vertical component. A vertical component to calculate that will go to B equals to U plus KT formula. I'll do it here. B is the one I have to calculate B2. U is the initial vertical component. Velocity component minus 10 times T is 2 seconds. So V2 is equal to 30 minus 20, 10 meters per second. 11 now. You have 2 ways of writing the final answer. In this question, the questions are given in concept RJ vectors. So you can write the final answer like this. Velocity at P. How? Velocity at P is the vertical horizontal component is 7I plus 10J meters per second. No problem. Or we can go to our first question pattern. Vertical, horizontal, vertical one is 10, horizontal one is 7. Calculate the resultant force. I'll take this as a resultant force, resultant vector. How to calculate it? Let's take it as let's take it as resultant velocity here VR or after 2 seconds in V2 or V dash it's easy for us now. V dash. Just a notation to give this one. So V dash is equals to square root of square of these two, n squared plus 7 squared sum of it. 149. So V dash is square root of 149 meters per second. But if you are doing like this, you will have to calculate the angle also. Tan alpha is equals to 10 divided by 7, which means alpha is equals to tan inverse 10 over 7. On over. Yeah. Alpha is equals to tan inverse 10 over 7. Okay. So if you are going like this, we know the velocity is square root of 149 meters per second and is tan inverse 10 over 7. Both ways you can represent. Okay, for the moment, write both. Write both. In exams, if it is given in IJ vectors, present in IJ vectors, no problem. If it is in general form, going like this is the IJ will. Okay, right. Try the fourth question and then we'll do a small theory part and then we'll move on to the second exercise. Someone is joining and leaving. I don't know who's the spy. Spy කෙනෙක් වගේනේ. එනවා. අඩි ගලක් වගේ නිකන්. So there is a set of students who has been selected for a special program. Other students are again list දෙකක් තියෙනවා. One is a set of students that have already selected. There's another set, another list actually 2 students are there who will do the checklist, based on their performance. I will putting them also to that category. Okay. Your programs will start from the third or fourth week of most probably from the fourth week of June. And we're starting a special program for you guys. Those who have been selected, they are not. Okay. So stay tuned with that group. Others, don't worry about anything. You also will be included in that category. It's based on your performance. If you are working really well, then you will be soon enter to that category. Try the fourth question quickly. Read the question carefully and try to draw a figure accordingly. What they say? A particle has been projected from an origin capital O at theta angle to the horizontal. Okay, the particle passes through point capital P at an angle elevation far from O. That's an important part. The direction of the particle, direction of the particle at P to the horizontal is beta. Okay, beta. So that tan theta is equal to 2 tan alpha minus tan beta. Now here beta, alpha, beta, theta, alpha, beta, theta, all three are there. A problem. That never confusing, right? Not confusing if you put that into a figure carefully. Listen. Listen now. So they say that a particle has been projected from an origin capital O. Okay, origin capital O. at a certain velocity. So, we don't know the velocity. I take the initial projection velocity as u. Okay. Otherwise, you won't be able to represent all of the data clearly. U at theta angle. Okay. So it passes through the point capital P at some point. It passes through point capital P at some point. It passes through some point capital P at some point. We don't know what point is that. So generally we'll take a random point. Now there's a special thing we are talking about. What means when it is passing through the capital P point, this particle is making an angle of elevation with, which is called as alpha. Which means, let's say, I am at point O and I project this. I project something and I'm observing it. So when I project something and when I'm observing it, when it is reaches point P, for me, I have to raise my eye somewhere from O. My elevation from here is given. Okay. Right. So the velocity vector is making a beta angle to the horizontal ground. Okay. Velocity vector is making a beta angle to the horizontal ground like this. Okay. The direction of the particle to the horizontal, sorry, direction of the particle to the horizontal ground is beta, which means this should be beta. Right. So I gave you the understanding. Still, I'll give you a couple of minutes. If I'm doing it my own, if I'm doing it by myself, I will be developing the projectile system, not you. You all are the people who's got waste exam. Okay. So let's say from this point O to point P, the horizontal displacement is X and the vertical displacement, let's take it as Y. Okay. So in this direction, okay, in this direction, because the time is not given, so we will have to find the time also. Own it because find your for the time you can put any value and continue. Right? T equals to T. So let's say this motion starts at T equals to 0. It reaches point P at when T equals to T. Right. In this direction, let's apply S equals to ut plus half at squared. Obviously, this half at squared is going to be 0. X, what is this u? I'm taking u. This is something I put. Having xy values, t values, then I put into the question. So in the final answer, we can't keep u, we can't keep p, we can't keep xy. We have to remove it. But do we have to be afraid to use those kind of conditions? You can feel free to use them. You have to be wise to do the simplification, right? So x equals to u cos theta. U cos theta. Our time, let's take it as t. This is going to be my first equation. This is going to be my first equation. This is going to be my first equation. So for the same motion, we'll apply this direction. S equals to ut plus half at squared. S is going to be the y. U sine theta minus half g, sine theta t minus half g t squared. Let's take it as second equation. Let's take it as second equation. So we have the vertical displacement and the horizontal displacement when it reaches point capital P. Alright. Then now there's a special decision that I'm making. So this is a vertical line, this is a horizontal line, this is 90. From these two, can't we connect these two and create a value for or create something related to this? You see? When the second equation is divided by the first equation, I'll use a different marker. When we divide the second equation by the first equation, we get y divided by x is equals to u sine theta t minus half gt square divided by u cos theta t. What is this y over x? If you try angle, what is this y over x? Tan alpha. This is tan alpha. On a tan alpha. Okay, tan alpha is equal to what? Tan alpha is equal to u sine theta t minus half gt squared divided by u cos theta t. So obviously this t cannot be equal to 0 because if it's t equals to 0, it's the beginning of the motion. So I'm going to divide t from numerator and the denominator. So tan alpha is equals to u sine theta minus half gt divided by u cos theta. Now give this u cos theta separately to both numerator values. We get tan alpha is equals to u divided by u sine theta divided by cos theta is tan theta minus half gt divided by u cos theta. This is my new equation. I'll take it as 3. Now we have created a part of our final answer. In our final answer, what they wanted us to find? They wanted us to prove that tan theta is equal to 2 tan alpha minus tan beta. So tan alpha, tan theta are there. So this is the part that I don't do. So by trying to remove this part, we can include beta. Maybe. So I'm going to multiply the equation by 2 to remove this 2. So you will get, I will take that equation as the next one. 2 tan alpha is equals to 2 tan theta, okay, minus gt over u cos theta. Let's take this as 3. Let's take this as 3. I'm multiplying the entire equation. But now give it a try to develop the next part. Just muted. Where did my mic go off? Where did my mic go off? At what point? Can someone tell me? From here. Okay, okay. So I will explain from that point. Listen now. So I'm going to apply V equals to U plus AT in this direction. What is this? The velocity. I'm applying for T equals to T positions, and when time is T, random selected time. You see, in this direction, the velocity component is V2. Initial velocity component is U sine theta. Gravitational acceleration is gt. What is v1? The horizontal velocity component. A horizontal velocity component doesn't change. No. Why? The horizontal velocity component is a constant. which is u cos theta. U cos theta. This is equals to u cos theta. I'm dividing these two. Why is that? When I divide these two, I can see I get V2 divided by V1. What is V2 divided by V1? V2 is the vertical velocity component, V1 is the horizontal velocity component at point capital P. If I am dividing these two, it's going to give you the tangent of this angle, right? How did we calculate the direction of the two perpendicular vectors? I mean, direction of the resultant vector of two perpendicular vectors by dividing the vertical component with dividing the vertical component by the horizontal component, right? That's how we calculated the directions. If you can't remember, go through the previous questions. See, right? So by dividing these two, V2 divided by V1, okay? By dividing these two, V2 divided by V1, we get u sine theta minus gt divided by u cos theta. Listen, V2 divided by V1 means tan theta. This is equals to u sine theta. Here, let's give this u cos theta separately. U and you cancel out. Sin divided by cos theta is tan theta minus gt divided by u cos theta. Let's take this as fourth equation. I'll give a substitution from this. We'll subject this minus gt cos theta. Minus gt cos theta, I'm going to substitute, so take tan theta the other side. We get tan theta minus tan theta. This is equals to minus gt over u cos theta. So this is 4. In 3, we have minus gt u cos theta. This is the complex part, or as the disturbing part, not the complex, but the disturbing part. We can give minus gt u cos theta, this entire, including the minus, and I can give a substitution from here. So from 3, 4, from third and fourth ones, what we can do? 2 tan alpha is equals to 2 tan theta minus gt u over u cos theta is equals to tan beta minus, this is plus, no, plus tan beta minus tan theta. So we get, you see, tan theta, 2 tan theta minus tan theta is tan theta. So 2 tan alpha is equals to tan theta plus tan theta. We have to subject tan theta, no? We have to subject tan theta, so take tan beta to the other side. You get 2 tan alpha minus tan beta equals to tan theta. So we'll write like this. Tan theta is equals to 2 tan alpha minus tan beta. This is what they wanted us to find or prove. Okay. A full question board. So this is somewhat almost similar to a 25 marks question, but not this much easier. But this is a good question. 25 marks also, this is worth it because the thinking part is good, no? The thinking part of this question is good. Except for one person, no one is asking for a break. You are at home, no? Ask your parents to feed you online. The physical class students are working nicely. Right. It's 10:50 until 11:10. I'll give you a 20 minutes break. Okay, you can have your breakfast and come. 20 minutes enough, no? It's 20 minutes enough. Guys, 20 minutes enough, no? So I don't, because we have to give a break for lunch also, right? Lunch is on in there. So see. Right. So now it's 10:50. So we will take a break till 11:10 a.m. Right, take a break and come. Take a break and come.
Guys, please wait. This Zoom is not getting connected from the laptop. Give me a minute. Give me a couple of minutes. I'll quickly get back to you soon.
Uh, can you please confirm, am I audible to you now? All good? I need individual responses. Previously, the laptop means the Wi-Fi did not get connected. Now fine, all good. I need individual responses. Quickly confirm it through the chat box. Am I audible? Is the board clearly visible? Okay, great. So write the subtopic. parabolic equations. Equations of parabolic curves. Equations of parabolic curves. So that's the last part of theory that we have to discuss, and then we can do the exercise 2, and then we can move on to past papers discussion as well, right? So you know, right? So now listen now. We'll take like this at point capital O, okay? I'm projecting a particle at the initial velocity U at theta angle to the horizontal, and the projectile goes like this. Goes like this. Right, draw with me quickly. Draw this with me. Okay. So I'm projecting when the time measurements starts at 0 seconds. So let's say when the time measurement is t equals to t at t seconds, the randomly selected time, the point is passing a capital, the particle is passing a capital P point, okay, which is in the vertical y vertical displacement and x horizontal displacement. Y vertical displacement and x horizontal displacement. Okay. Draw and write with me. Huh? Right. So here, this is something that we already discussed, that additionally we are discussing once again about that. Very good. Right. So in this direction, I'm going to apply x equals to ut plus half at squared. So here see, in this direction, the horizontal displacement is x. Okay, before you apply the formula, you have to now something important that I'm pointing out. In previous questions, I did not point out this one. So we recommend that when we apply these linear motion equations to projectiles or linear motions or any motion related lesson or any motion related problem solving, when you are applying linear motion, you have to either mention for the time frame or for the motion that you are applying to. So here I am applying to O to P motion, right? O to P motion, or as when T equals to T time frame you apply. So better to write it like this: O to P motion I am considering. Considering O to P motion, if I apply S equals to ut plus half at squared. What is S? The horizontal displacement, which is x. Initial velocity is going to be u cos theta. Time is going to be t. This one is going to be 0 because the horizontal acceleration is 0. This is my first equation. And to the same O to P motion, I'm going to apply S equals to ut plus half at squared in this direction. Listen carefully. What is this? What is S? Y. This is equals to what is U put up? U sine theta t plus the minus. I am applying in this direction now. Is going to be minus because acceleration is minus. G t square. This is my second equation. Right? Quickly do until this point with me. Okay. Fine. So here, so let's think that x horizontal displacement and the vertical displacements are given. Then we can say x equals to. So let's say the horizontal displacement is given to you. If it is given, let's say t is something that you have to find. T is something that you have to find, or the time you have to find. So from 1, I'm going to subject t. If I subject t, we get what for the? If you subject t, we get x divided by u cos theta. Let's take it as capital A equation. So I'm going to substitute this capital A in our second equation. I'm going to substitute this capital A in our second equation. Substitute and write, will you? Substitute and write. So what do you get? From A and 2, we get y equals to, this is y, yeah, not g. Y equals to u sine theta t. What is t? T is x over u cos theta. X over u cos theta minus half g. What is t squared? T squared means x over u cos theta complete square. Complete square. Now here's here. Y equals to u and u cancelling out. X times tan theta, or is tan theta x. X times tan theta minus, you see, g, this one is x squared over u squared cos squared theta. I write like this, g over 2 times u squared cos squared theta x squared. Here, x squared u squared cos squared theta. I'm u square cos square theta, I'm giving it this 2 times u square cos square theta. In the numerator, I am writing g, the x square separately write. So what do we have here? We have y equals to, listen carefully, minus g over 2u squared cos squared theta times x squared plus tan theta x. What is this, Pudha? This is a quadratic function. So what is this y? Y is our vertical displacement. What is x? Horizontal. Okay. Y is vertical displacement. What is x? Horizontal displacement. So we can see that when we rapidly here, horizontal displacement is gradually increasing. When we are increasing the x values, the behavior of y values is given by this function. That's a function. So here in all of us, you are learning graphs. You don't know where, in what kind of instances we are using graph. Maybe you might have asked your lecturers in all levels, why is it we are learning this stuff? We are going to use it. Here's one application. We can explain the vertical displacement of a projectile motion based on the horizontal displacement of the projectile motion. When we gradually increase the horizontal displacement of a projectile, the vertical displacement gradually increases, and at some point it reaches the maximum and then it decreases. So can you see? This is what for y, a negative coefficient of x squared. We know if the coefficient of x squared term is negative, we get a maximum graph, maximum parabola. It has a maximum turning point, which means this y, the vertical displacement, has a maximum value. Okay. So the changes of this vertical displacement is explained by the horizontal displacement. By changing or increasing horizontal displacement, we can explain the vertical displacement behavior. When the horizontal displacement gradually increases, vertical displacement increases, come to a maximum point, and then it starts to decrease. Aputa, idea is super important. Okay, right. Quickly take this note, understand and do it. Understand and write this quickly. Done. Finish it. Okay. May other MathLab applications, sorry. That's why we call this applied mathematics. If you want, you can reform this one as taking this 1 over cos square theta as x square theta. You can write like that, no problem. But I'll keep like this. Now take your cube. Take your cube. In exercise number 2, do the question number 5. Do the question number 5 from exercise number 2. Try the fifth question quickly. I'll give you 1 more minute and then I'll start the discussion. Right, done. Right. So they say that a particle is projected from capital O, projected from point capital O with an initial velocity of 50 meters per second at an angle inclined to the horizontal. So we don't know at what angle inclined to the horizontal. They didn't give you a fixed value or a known value. So you can go with a notation like theta O, alpha O, anything. Okay, and start your discussion. So in the middle of the discussions, you may be able to find the unknown terms, or we may be able to ignore those parts and do. Right. So what they say, a particle is projected from capital O point with an initial velocity of 50 meters per second at an angle inclined to the horizontal. So from capital O point, a particle is projected. So I don't know at what angle they are projecting it. So I will take the initial velocity as u and the projection angle as theta. Right. Now what they say, sorry, they gave you the initial velocity, no, 50 meters per second. It is given, sorry. 50 meters per second. It is given. Now what they say, the particle passes through a fixed point P, which is located 10 meters above the horizontal ground, horizontal from point capital O. This passes through a capital P point somewhere, which is 10 meters away from the horizontal ground. Okay, 10 meters above the horizontal ground, which means the vertical displacement is 10 meters. Horizontal displacement is 30 meters. 30 meters away from capital O. So marking these data clearly solves half of the question, okay? Now here, next what they say, show that the particle could have two possible projections. If those projection angles are alpha and beta, show that tan alpha plus beta is -3. Calculate the difference between the times taken by the particles to reach point P under the two possible projections. Now the question this question is a common question to the most of the questions you will be able to find this and even in my papers, because this is one of the difficult type of questions you will get in projectiles. So here they are saying, in order to mimic this same exact situation, there is another projection direction. When we project this particle at a certain angle with 50 meters per second, okay, to pass the point that is 30 meters away from the projected point and 10 meters above the projected point. To mimic the same situation, there may be another projection direction, maybe not this direction. There will be another one which is 10 meters above the projection line and 30 meters away from it. Okay, or else maybe there's another projection like this which could do the same thing. Okay, so obviously should be the other side. So they are asking what are the, you have to prove that it has two such directions. First of all, you have to prove that it has two such directions. Now remember, if it is having two such directions, this is the ultimate idea. In mathematics, if we have to explain or find properties or things that is having the same behavior, it is enough to find one thing. It is enough to put an effort to find one thing. Automatically, you will get the other one. We discuss the same idea in vectors also. Okay. There was a question that like one vector is perpendicular to another vector. We wanted to find the coordinates of point C and D. And I told you, trying to find point C is enough. You will automatically get point D. Or trying to find point D is enough. Automatically, you will get point C. Like that, here also, trying to find the projection angle, trying to find one projection angle is enough. When you are solving, you will get two answers, which means two projection directions. Okay, so trying to find this theta. When you try to find this theta, if you are getting two answers, it means there are two projection directions. One is in this direction, the other one is in other angle direction. Okay, so my ultimate goal is to find this theta here, right? So this question is important. Put a star mark and write. Before we perform the question, put a star mark and write. Put a star mark and write. Put a star mark and write. Before we solve the question, let's take a note under this question. Put a star mark and write. We need to prove that. There are two possible projection directions. There are two possible projection directions. Two possible projecting directions for the particle. Such way that it passes through a point, 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 such way that it passes through a point that is 10 meters above the horizontal, that is 10 meters above the horizontal, and 30 meters away from the projected point. 30 meters away from the projected point. Separately write. Since both projections के लिए since both projectiles means if you project in both directions they are asking, both directions they want us to find. Okay, right, like this. Since both projectiles inside the brackets, right, projected through two possible directions. Projected through the two possible directions inside the brackets, right? Projected through the two possible directions. Close the brackets. We'll have the same we'll have the same curve. We have the same curve. So maybe it's one is from this side, the other one is from the other side. Inside the brackets, right? Inside brackets, right? Brackets on net. Separately, right? Trying to find one projecting direction. Trying to find one projecting direction. Trying to find one projecting direction. Trying to find one projecting direction is enough. Put a comma. As it will automatically give the other direction. It will automatically gives the other direction. Right. That's the understanding. Now you just have to manipulate the equations you have. Okay. Slowly. Yes. Now what we can do is okay. I'll give you an idea. You have to try to do this. We know at this point we have vertical velocity component, horizontal velocity component. We know the vertical displacement, horizontal displacement. Start from the known point. Start from where you know. So let's take this time as t equals to 0. It reaches P point when P is equal to T. From O to P motion, you can apply the formulas vertical displacement for the horizontal displacement and try to find the time taken to travel from O to P. We can easily find it by considering only the horizontal displacement, and you can develop the equations and try to find theta. Give it a try. I'm lazy. Make a lazy equation. Once you get the idea, question is easy. I'll give you 1 minute.
Think a little bit, you will get a quadratic equation of tan theta. Get a quadratic equation of tan theta. You don't have to solve tan quadratic equation, but you can consider the discriminant and say check the sign of the discriminant, do an inference, do an interpretation. I'm giving you time, you have to think this. Karena hadala පුරුදු වෙන්න ඕන. So I think I have given you more than enough time to think. Hurry. Now listen to my discussion very carefully. Hurry. Listen. What I'm going to do is, we know the vertical and the horizontal components of this one. The horizontal component is 50 cos theta. This one, vertical component is 50 sin theta. Right. For O to P motion, or as to for O to P motion, they are applying these equations. You see, to the horizontal direction, I'm applying S equals to UT plus half AT squared. What do you get to that? What is S? Horizontal displacement 30. This is equals to initial velocity, horizontal velocity component 50 cos theta t. Half AT square, this one becomes 0. So let's subject t from here. T is equals to 30 over 50 cos theta. So I'll write it as t equals to 0 and 0 cancelling out. 3 over 5 cos theta. We'll take it as first equation. So I'll do the calculation here. Or to the same O to P motion. In this direction, I'm going to apply S equals to UT plus half AT squared. Why I'm doing that? Because I can see the known data 30 and 10. So start from there. Vertical displacement is 10. U means vertical initial velocity component 50 sin theta. T minus half. A means the gravitational acceleration, G T square. You can take it as G and do for the moment. Go with the letter G. So now here, see, listen carefully. We know the T value is equals to 3 over 5 cos theta. So I can substitute 10 equals to 50 times sin theta times T is equals to 3 over 5 cos theta. 3 over 5 cos theta minus half times G 3 over 5 cos theta complete square GT square. Simplify 10 equals to simplify this, you get this and this cancelling now. 130 sin theta minus let's simplify with G also. Simplify lazy. So take G as 10, keeping the notations. In the question, did I give you take G as 10? Right, come on, take G as 10 now. Right. So this one and this one cancelling out 5. This is 25. 5 and 25, when I cancel 5, you will get 9 over 5. 9 over 5 sec theta. So this is sin theta or cos theta. This will be tan theta. So let's take this as second equation. Now think. Oh, sorry, this is sec theta. No, sec squared theta. This is sec squared theta. Right? We'll take it as second equation. But from here itself we can solve, no? Yeah. What is sec squared theta? 1 plus tan squared theta. By simplifying this one, I got this one. 2 divided by 10 divided by 2 is 5. 5 square is 25. 5 and 25 cancelling out 5. 3 squared is 9. 1 over cos square theta is sec square theta, which is 1 plus tan square theta. So I'll take it as second equation and I'm going to modify it further. 30 tan theta minus 9 over 5 sec square theta means 1 plus tan square theta. Multiply both sides by 5, you'll get 50 equals to 150 tan theta minus 9 tan square theta. So I'm taking all the terms to one side, so I get 9 tan square theta minus 150 tan theta, okay, plus 50 plus 9 plus 59 equal to 0. I'm taking all these terms to this side. So what did I get? A quadratic equation of tan theta. So this is a quadratic equation of tan theta. So quadratic, it can be a quadratic equation of the variable is tan theta in this case, not x. We are used to x, no, but this is a quadratic equation of tan theta. We know quadratic equations of tan, any quadratic equation. Before solving, we can decide whether it is giving us real distinct roots or one real root or no real roots. We can find it by considering its discriminant. So I'm going to let us consider the discriminant delta. So how the discriminant is defined? A coefficient of the if it is let's assume like this is 9x squared minus 150x plus 59 equal to 0. How do you write the discriminant to the minus 150 complete square minus 4 times 8 times c. So the same thing. This is the square term coefficient. This is the something like the x term or as the linear term, degree 1 term. This one square, b squared minus 4 is, this is the place, in the place of b we have minus 150. So minus 150 complete square minus 4 times a is coefficient of x squared term or as in this case tan square theta term 9 times constant is 59. So simplify and get the value of delta quickly, then whether this is positive or negative. Simplify and tell me current simplify. Simplify and tell me. I'm considering the discriminant delta for this tan quadratic function. Sorry, quadratic equation in this case. You get an answer that is positive. You must get an answer that is positive. In a comma, it's correct, no? Minus squared is plus 15 into 15 means 225. 225 you get 225 double z, which means 22,500. So 4 times 9 is 36. 36 times 59 is not close to 22,500, no? Right? Double check. $2,124, no? Yeah, it's going to be positive. This is going to be positive. Make a positive. Now let's get back to the quadratic equations lesson. Make a complete correct even before we start trigonometry, okay? Even before we do trigonometry, I started quadratics and we finished it. We did a 30 now, seminar or something also. Alright. We know that if the discriminant is positive in a quadratic equation, if the discriminant is positive, we know that if the corresponding graph of the function is going to cut the x-axis at 2 points. We have two distinct real roots. So discriminant is greater than 0 means this tan square theta, this quadratic function of tan theta. So the quadratic equation of tan theta has two distinct real roots. If it is a quadratic equation of x, we get roots for x. X equals to 3, x equals to 4. If it is a quadratic equation of tan theta, then we get the roots for tan theta. Tan theta equals to one answer, tan theta equals to another answer. Two different answers for tan theta. We get two different answers for theta. What is theta? If we get two different answers for theta, it means what? Two different projection directions. Two different directions we project the particle. All right. Put a star mark. Now, put a star mark. Below this one, you don't have to solve. You have to write the answer in your understanding. Clearly state the reason. Clearly state the reason like this, right? Write with me. Write with me. The discriminant delta of the quadratic equation is positive. The discriminant 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 of the quadratic equation is positive. Quadratic equation is positive. Therefore, the corresponding graph of the function, the corresponding graph of the function, therefore the corresponding graph of the function intersects the x-axis, intersects the x-axis at two distinct points. At two distinct points. Intersects the x-axis at two distinct points. At two distinct points. At two distinct points. Therefore, this quadratic equation, therefore, this quadratic equation has two roots. Therefore, this quadratic equation has two roots. Two roots. Two roots. Two roots. Two roots. Right? Therefore, there are two possible directions. There are two possible directions. There are two possible directions that the particle could be projected. That the particle could be projected. That the particle could be projected such way that it passes through such way that it passes through point P, capital P, yeah, such way that it passes through point capital P. Okay, maybe clearly you have to explain what's happening. Okay, this part, this if they are giving this kind of big questions, you will not get this one in short question paper. Okay, මෙහෙම දෙනවා නම් essay question එකේ එන්නේ. If they are giving the question like this, then the question will be in essay paper. Okay, right? Because there are a lot more sections to complete in this. Now listen. Stop working and listen. Now what did we identify? Then පුතා මෙතනින් පස්සේ discussion is going to take another 10 to 15 minutes time continuously. Okay, to solve this question. In the what I recommend is from top to bottom until this point, whatever things we discussed so far, just go through that. I'll give you 2 to 3 minutes quickly. Put a go through them, otherwise you won't understand the other one. And if you have anything missed, quickly complete the note. Right. Now listen now. Now listen carefully. Then this is an important idea. When we solve a quadratic equation, we get answers for the variable. If it is a quadratic equation of x, we get the values for x. If it is a quadratic equation of y, we get roots for y or solutions for y. If it is a quadratic equation of tan square tan theta, we get answers for tan theta, right? They say that now first of all get this idea. What does it mean by projecting the particle in two different directions such way that it passes through point P? The question is, prove that it has two possible directions such way that it passes through point P, which is 30 meters away from the projection point and 30 meters above the projection point. So 10 meters above the projection point. Such way they asking two possible directions, which means Pudha, it can happen this way, You project the particle at a certain angle and it goes through this point P. Okay, this is one way. Or else you project through another greater angle which has something like this. Okay, if you complete the projection, this projectile goes like this projectile goes like this. Possible? But both projectiles are going to go through this point capital P. But it's still what we have. One direction such way that it goes through P, another direction such way that it goes through point capital P. Can this happen only in this side? No, it can happen on the other side as well, no? Keep that idea in your head because we need that idea to do the next few discussions. Another time difference එකක් අහලා දෙනවා නේද? Now, that's one idea. The next thing. This one will give two distinct roots. Those two roots are going to be the values for tan theta. They are saying in the question, if those two possible directions are alpha and beta, if those two possible directions are alpha and beta, they didn't specifically mention whether alpha is big or beta is big. Obviously, one is bigger than the other one. Then only we can get such appearance. One is like this and the other one is like this. Both are going to go through this point P. One angle is obviously greater than the other one, bigger than the other one. But here in this question, they didn't specifically mention who is going to be bigger. Right? So, which angle is bigger, we don't need it significantly. There is a way that we can ignore the impact of that confusion. Okay, we'll discuss that. However, when you solve this quadratic equation of tan theta, you will get answers for tan theta. What are the answers you get? Two different values for tan theta, which means two different values for theta. Right? So one value is theta equals to tan inverse something, and another value is theta equals to if you solve this one, you get tan theta equals to one answer, and another tan theta is equals to another answer, which means theta equals to tan inverse something, and theta is equal to tan inverse another thing. Right? So you will get two different projection directions, two different answers. This is an angle. One angle is alpha, the other angle is beta. Okay, one angle is alpha, the other angle is beta. Which means if I think backwards, then the solutions are going to be one solution is tan alpha, the other solution is tan beta. Basically, I'm considering here theta can be equal to alpha, theta is equal to beta. These are first of all, they want us to prove that there are two possible directions. We proved it. That's the proving part only we wrote it in words. Now we proved it there are two possible directions. Now what they say, the two possible directions you proved. Now think that the two possible directions are alpha and beta. Now we know this theta should get two values. One is alpha, the other is beta. We know quadratic function is a quadratic equation is going to get r into tan theta. No? So theta equals to alpha, tan theta is equal to tan alpha. Theta equals to beta, tan theta equals to tan beta. So the solutions you get for this quadratic equation of tan theta will be tan theta equals to tan alpha, one root, the other is tan beta. So the quadratic equation's roots are tan theta and tan theta equals to tan alpha and tan theta equals to tan beta. So I'm going to write since the projecting directions are alpha and beta, root of, let's take this quadratic equation as capital A here, roots of A will be tan theta equals to tan alpha, comma, tan theta equals to tan beta. If it is x, x equals to something, x equals to something, here you will get this also tan theta. Now, Puta, we know sum of the roots. How do you write it? Sum of the roots equals to coefficient of x minus times coefficient of this single variable, which is minus 150, divided by the constant 9. Matagane alpha plus beta, if alpha and beta are the roots, minus b over a, alpha beta is equals to c over a karani. The same thing, sum of the roots equals to minus times coefficient of the linear term divided by the coefficient of the square term. Now this one will give you tan alpha plus tan beta. Projectiles here, right? Now we are doing not projectiles, we are doing quantities. Okay, minus into minus plus 150 divided by 9. 150 divided by 3 is 50. 9 divided by 3 is 3. Let's take like this. We'll take it as 1, 2, third equation. Product of the roots, how do you write it? The roots are tan alpha and tan beta, so the product of the roots will be tan alpha times tan beta. This is equals to C over A. What is C? 59. That is A? 9. Right. This is my fourth equation. Now, Puta, what did they want us to find? Tan alpha plus beta value. Next, what they wanted us to show that tan alpha plus beta is equals to minus 3. Okay. Method finish and confirm me through the chat box online, student. Until this point, I didn't erase the board anywhere. Are you guys clear with this or any unclear part? Now itself ask because we don't have time to come back and discuss this one again here. Students, those who are in YouTube live, you will have to get a message in the WhatsApp or you have to join the Zoom meeting and drop the message. All good? Understood? Everyone, I need individual responses. Individual responses means individual responses. I have responses from few. What about the others? Quickly. Only few people respond. What about the others? Neither. If you did not respond, I don't know, but I don't have a third eye now. If you have a doubt, now itself ask. Complete until this point. Complete until this point. The decision making and how to connect the previous lessons knowledge is super important. The method projectiles actually finished equations projectile right? Equations projectiles. So is it okay to use the equation from the previous now to get the quadratic equation of tan theta? You will have to do it from scratch. You can't directly take a derived equation from another equation and apply the values and take it. Not possible. You will have to do it from scratch. Yeah, that's a problem with Zoom, Mikram. I can't help it. Okay, no? Right. Then I will have to erase the board, this part. Make erase කරන්න වෙනවා. What are we? Do the question, finish the question. Right. So I'll erase this part. So we want to find tan alpha plus beta value. So simply consider tan alpha plus beta. You see, when we take, listen now, tan alpha plus beta, this equals to tan first angle plus tan second angle divided by 1 minus tan first angle times tan second angle. So tan alpha plus tan beta is given 50 over 3 divided by 1 minus tan alpha tan beta is given 59 over 9. Simplify. Take 9 here. Take a common denominator here. I'm going to simplify. Yeah. This is 50 over 3. What do we get? This is equals to tan alpha plus beta. This is 50 over 3 division. 9 comes here. 9 minus 50 here. I'm taking common denominator 9 over 9. 9 minus 59 is minus 50 over 9. When we convert it to a multiplication, this becomes minus 9 over 50. 50 and 50 cancelling out. 9 divided by 3 is minus 3. So tan alpha plus beta is equals to minus 3. It's right. Harane? Last center. Put the rate in a box. Tan alpha plus beta is equals to minus 3. Okay. Next, what they say. This is a good question now. I get the I told you exercise 1 easy, exercise 2 is hard, exercise 3 is past paper. So compared to exercise 1, exercise 2 and 3 are hard. Compared to exercise 3, exercise 2 is hard. That's how we prepare the question. We have to discuss basic stuff and we have to discuss the advanced stuff than the A-level exam. Advanced, but some thinkings are there. A-level questions, A-level paper questions are not this much simplifications involved. Simplifications are easy. But the initial decision making is going to be difficult. Decision making is going to be difficult. Harane? Okay, right. So I need the first equation, and now what they are asking us to show that the time difference, calculate the difference between the times taken by the particles to reach point P under the two possible these things. Here we listen very carefully. This part is very important. I will be erasing the board. I need the first equation and second equation. Number 1, 2, those two equations I will need the. I'll be erasing the board. Okay. So let's recall the first equation. What was the first equation? T equals to 3 over 5 times cos theta. 3 over 5 times cos theta. Then balangin. Listen now. From this one, what I'm going to do is I will subject cos theta. 3 over 5 times t. Let's take it as 1 dash. What's the second equation? What's the second equation? Do it. Didn't write. Didn't? What happened? You did try to didn't write. Then no, don't know how to read. Then, so what's the second equation? Someone can send me the second equation to them. What was the second equation? No. Ang erase karana kali Q adina or ye. Ne. You will mark the second equation as number 2. Good. Someone send me the first two equations. So I have accepted them. Someone please send me the first two equations via WhatsApp quickly. Aida or someone quickly. The first few parts of the question. I need the equations. That's all. Okay. So the second equation is 10 equals to 30 tan theta minus 9 over 5 sec square theta. Harane? Right. I will take this as the second equation. You see? Can you remember we applied U S equals to ut plus half a t square for O to P motion. Okay. What is S? 10 equals to U is what to the of the U. Second equation was substituting t value from this. Without substituting, I'm going to take it. What is U? 50 sine theta t minus half times 10 t square. So this is going to be 10 equals to 50 sine theta t minus 5t square. Why I'm keeping like this? So that if you want, you can substitute t with 3 or 5 cos theta and take it. That was the second equation. But I'm not going to take that second equation. I'm going to take one step before that. Make run. Okay. Listen, divide both sides by 5. We get 2 equals 10 sine theta t minus 5 minus t squared. Subject sine theta from this. You get 2 plus t squared divided by 10t is equals to sine theta. Where sine theta is equals to, when you are marking the data, properly mark them, right? Sine theta is equals to, divide both values by 10t, you get 1 over 5t plus 1 over, t over 10. 1 over 5t plus t over 10. Let's take it as 2 dash t lama, no problem. Alright, finish until this point quickly. Finish until this point. Finish until this point. Now the thing is, keeping the theta and solving the question is going to melt your brain, while there are no possible ways of easily simplifying that. So my target is to eliminate the theta terms. How am I supposed to do that? How we can do that? How we possibly can do that? What I'm going to do is, I'm going to add the 1 dash equations square plus 2 dash equations square. 1 dash equation is this cos square theta plus 2 dash equation is sine theta. I take it as sine square theta. This is equals to 9 over 25 t square plus 1 over 5t plus t over 10. 1 over 5t plus t over 10. This one's complete square. I'm squaring both first and 1 dash and 2 dash equations. Simplify this. Simplify quickly. Simplify quickly. The left hand side you have 1, no? This is 1. So you get 1 equals to 9 over 25 t squared plus 1 over 25 t squared plus 1 over 25. These two multiplied by 2 here. This is a square of a binomial expression. First term squared, 2 times the product of these two. When you take the product of these two, t and t cancelling out. So 1 over 5 multiplied by 1 over 10, multiplied by 2 again. So 1 over 10 and 2, I can cancel 1 over 5. Basically, when you simplify this one, 2 times the product of these two is 1 over 25. Following run the simplifications. Plus this one is going to be t squared over 10. T squared over 10. So multiply both sides by t squared. So you get t squared equals to 9 over 25 plus 1 over 25 plus t squared over 25 plus t to the power 4 over 10. So all t's in the denominator has been removed now. Now you see, this one is 9 over, sorry, 25 is the common denominator. This is 10 over 25, no? Multiply the entire equation by 25 to get 25 t squared equals to, listen carefully, okay? Listen very carefully. Multiply entire equation by 25, you will get 25 here, 25 t squared, 10 plus t squared plus multiply by 25, you will get 5 over 2 t to the power 4. Alright, complex setup. I'm trying to make it simpler. This is just a simplification. Now I can see most of the denominators have 25, so I multiply 25 to remove the denominator 25. When I multiply this one by 25, 10 divided by 5 is 2, 25 divided by 5 is 5, I get something like this. Now the only disturbing part is this 2. Multiply the entire equation by 2, you will get 50t squared is equals to 20 plus 2t squared plus 5t to the power 4. So take 2t squared to the other side minus 2t squared. So you get 48t squared. Take all the terms to the other side. So you will get 5t to the power 4 minus 48t squared plus 20 equals to 0. Plus 20 equals to 0. Now what is this, Buddha? Make out the way. What is this? This is a quadratic equation of t square. This is the quadratic equation of t square. 5 t square plus square minus 48 t square plus 20 is equal to 0. Something like, if t squared equals to x, think that if t squared is equals to x, what is this? 5x square minus 48x plus 20. So this is what we have here. Another quadratic equation. Another quadratic equation. මං හිතලමයි මේ ගාන දැම්මේ. මං දන්නවා උඹලට quadratics මතක නැහැ කියලා. Right? වැඩ කරන්නේ නැහනේ. Just coming to the class, going home, all parwage කනවා බොනවා නිදා ගන්නවා, real life Garfield simulation එකකට ඔයාලගේ life වෙන්නේ. Right? So now we are done with the trigonometry. Coplanar forces almost done. Sunday we completed halfway to only the moment part and the couples part was there. Actually, I was supposed to finish it last Sunday, but the participation was not good that time. We had to stop it in the middle. Okay. So this Thursday I'll be finishing coplanar forces, those parts. Projectiles with Yorunana. I'll be in applied mathematics. Next part we are going to start is this one, equilibrium. After equilibrium, I'll be moving on to relative motion. Okay, relative motion. I mean, basically the other motion types. Under motions, you have projectile motion, linear motion, or as motion in a straight line, and then circular motion, and then relative motion. Under relative motion, you have two parts: relative acceleration, relative velocity. So parts of So in the second stage, the 10 is in squared. Yeah. T square over 100. Even I'm when I multiply this one by 25, this becomes 4. When I multiply this one by, sorry, this becomes, this is, I multiply t squared, no, this is 100. Then we multiply by 25, this is removed, this is t square, this one is 10 or 25, no? 25, this is removed, this is removed. When you multiply by 25, this is t over 4. Sorry, t to the power 4 divided by 4. So I'm multiplying with 4 again. Huh? These ones will change. When I multiply with 4, we get 100 t squared, 40 plus 40 squared plus t to the power 4. So we get t to the power 4 minus 96 t squared plus 40 equal to 0. I'm taking all the terms to the other side. So one side is 0, one side we have the quadratic equation. So this is t squared whole square minus 96 t squared plus 40 equals to 0. Then listen, will you? This is a quadratic equation of t square, not t, no. This is a quadratic equation of t squared. T equal square. So one can tell me, when I saw this quadratic equation, what are the I'm getting solutions for what? T squared relative. If I solve this one, I'm getting the solutions for t squared, not for t, because there is a quadratic equation of t squared. So if I solve this one, I get solutions for t squared. No? T squared relative, I'm getting solutions. T squared equals to one answer, t squared equals to another answer. Can you see? T squared equals to one answer, t squared equals to another answer. When I take the square root, I get two answers. Each one will get two answers because modulus is going to be minus. Okay, one answer could be minus. Minus not candidate because this is the time. T means the time. But could be the opposite direction, no? Other direction, like for an example, think about this is a constant. This is an important understanding. Okay, we know the time is not measured in negative, right? Times are not measured in negative, but we can imagine like this. This is the timeline. Okay. If I'm projecting this way, I'm measuring the time positive. If I'm projecting opposite direction, I'm measuring the time negative. Negative time is that doesn't mean I'm changing. Negative time means I'm just considering the other side of the projectile. That's it. Otherwise, time is negative or not. I'm not making time. I'm not making time. And I'm just marking this margin as absolute zero. That's it. That's one way to think. That's the we get answers for what? For t squared, right? T squared squared. We get answer for t squared, which means t squared will have two answers. When you solve, and if you come until this point, I'll give you a note. Finish until this point. I need space also on the board. So finish until this point. You first quickly. Done. You wrote. Everyone done until this point? Finished. Everyone completed until this? Yes or no? Okay, put a star mark and write. Put a star mark and write. Put a star mark and write. We have a quadratic equation of t square. 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 T square. Which means you have a quadratic equation of t square, which means we get two distinct solutions for t square. We get two distinct solutions for t square. This is not an answer, but this is just a note that I'm giving for your reference. Okay, t square. Practically, Practically, this means practically this means that that the particle can take, practically this means that particle can have, take no, particle can have two possible directions inside the brackets, right? Two possible timings two possible directions, two possible timings, close the brackets, such that it passes through point capital P. Point capital P. Point capital P. Point capital P. Put a comma. In two duplicated situations. In two duplicated situations. In two duplicated situations. Then ngahang ind. Alut scene ekak. Alut scene ekak. This is something that really important to understand. Now you should be able to practically think about this and interpret it. Then can you see? I got the equation t to the power 4. Let's get back to the polynomials. We know that if a polynomial has only one degree, if it is a degree 1 polynomial, if it is a linear equation, degree 1 equation, we have only one solution. If it is a degree 2 equation, we have maximum of 2 solutions. If it is a degree 3 polynomial, degree 3 equation, we have maximum of 3 solutions. If it is a degree 4 polynomial or degree 4 equation, we get maximum of 4 solutions. Maximum of 4 solutions. Element of this t to the power 4 should have 4 solutions for this one, no? 4 solutions for this one. Why 4 solutions? They didn't tell you that the particle, practically maybe it's happening in one direction. But mathematical equations are actually going to give you all the possible outcomes. It is maths Maths equations not going to explain what you really desire. Maths is going to give you the entire idea of practically what's happening. This equation suggesting us there are 4 different times that it could reach point capital P. 4 different times, but only we have two different projection angles, no? Alpha and beta. Alpha will project karo, you get 1 time, beta will you get 1 time. So practically you should get only 2 answers. Okay. But you get 4 answers in here. According to this one. What does that mean? Putta, method in alpha you project like this, it goes to a point that is 10 meters above and 30 meters away, And if you project with, let's say, alpha, beta, minimum, in case if it is like this, okay, alpha is like this, beta is like this now. This is going like this, going through the same point, which is 30 meters away from this projectile point and 30 meters above. The same alpha beta can be done from this side also. අපිට හිතුන්නේ නැති වුණාට maths වලට හිතනවා. We might not be sensible for all the possible outcomes, but mathematics is sensible. That's why equation is suggesting යකෝ උඹට කිව්වට මට හතරක් වෙනවා. You may say there are two timings, but I see 4 timings. But the 4 timings කොහොමද වෙන්නේ? Just because I change the side, I'm projecting on right hand side, or I'm projecting from the left hand side. Just because I change the side, that doesn't mean the projectile is going to change. Whatever the time that is taken when you project in this side, the same time is taken when you project an alpha from this side also. Whatever the time that is taken when you project from this beta to this side, the same time is taken here when you project beta to this side. This equation is going to give you 4 different four t values or 4 solutions. Practically speaking, those 4 solutions are not going to be 4 different solutions. Same solution repeated twice. That's not duplicated. It suggests okay. We have 2 possible directions, which means 2 possible timings that we could reach P in a duplicated manner. Method of taking T equals to T1 to reach P at when you project from alpha angle, and if it is takes T equals to T2 times when you project beta angle, the same T equals to T1 and T equals to T2 are taken from here. You are going to get the same timing for the same angles. The solutions, when you take, I will take this one here. I will write this t to the power 4 minus 96t square plus 40 equals to 0. So the roots are going to be t1 comma t1 comma t2 comma t2. Same solution repeated. This one is for alpha from right hand side. This one is for alpha from left hand side. Alpha beta from right hand side, beta from the left hand side. When I modify this quadratic equation such way, it looks like this. Our roots are going to be what? The duplicated roots. When I'm logging like this, I get answers for t squared, which means I get t1 square comma t2 square. Omega q. Roots are going to be like this. Right, that's the basic idea. Roots are going to be like this. Then if the roots are like this, we know sum of the roots given. What is t1? t1 is the time taken when you project at alpha angle. t2 is the time you will get a time taken to reach point P when you project at beta angle. Correct? Sum of the roots equals to what? Minus times coefficient of this is t square this term, no? Minus 96 divided by 1, which is 96. This is my, I think 1, 2, 3, 4. Let's take it as 5. Product of this thing is equals to 40 divided by 1. Let's take it as 6. Considering these two, you can calculate, but they are asking the difference between the timings. So it can be t1 minus t2 or t2 minus t1. Then thinking but I did. Then I'm answering. Understood. See how beautiful the question is online, students. Clear with that? Understood? Maths ලස්සනයි. The connection Connecting the dots and connecting the other lessons and connecting the practical application gives you kind of an author. යාතු විස්තර ගන්න එපා. අනින් හිතන වැඩ කරන්න ඕන. හිතලා කරන්න. So what do we have to find? The difference between the timings it reaches point P when it is projected by two possible directions, right? So difference between the timings can be, maybe if alpha is big, the timing is going to be maybe greater or less. Actually, alpha angle the lower angle gives you a bigger dispersion. Greater angle, a smaller distance, right? So difference between the times. So maybe T1, if the T1 means T1 minus T2, if you directly say wrong, right? You might get a negative answer if T2 is big. If you take T2 minus T1, that is also wrong. The difference between the two timings, right? T2 can be big. So T1 can be big. Then what's the wisest thing? Lazy modulus of T1 minus T2. Modulus is obviously going to give you the magnitude of the difference. So it can be T1 big or T2 big, that doesn't matter. It's going to be positive also. If you take T2 minus T1 also, no problem. Half is going to be the same. This one is what Buddha? Now, this is what we have to calculate, right? Module, this one is going to give you what? A real number, a number. You know, modulus of a real number is taken, modulus of a real number means what? A squared square root of it. Square of a real number, if you take the square root, it's equals to modulus of that. We can rewrite it as square root of T1 minus T2 complete square. If you take T2 minus T1 complete square, no problem, the same answer you are going to get. So this is equals to square root. Expand this T1 square minus 2 times T1 T2. Okay, T1 T2 plus T2 complete square. Let's write here T1 minus T2 is equals to square root of T1 square plus T2 square is equals to 96. Okay, minus 2 times, what is this? T1 times T2 gives the square root of this one. What is a positive answer? If you take the square, it's going to be what? Square root of 40. Hurry. So this is equals to square root of 96 minus 40 means 4 times 10. 4 times 10, 4 times 10. It's going to be 4 root 10. Oh, make up now. I think 96 and 4 from both you can take a 4 outside, no? 4 has a common factor outside. Right? So 4 times 24 is 96. So I can take 4 as a common factor outside. 4 times 24 minus square root of 10. So you get, take 4 outside, 2 square root of it. 24 minus square root of 10. This is what we get as the difference between the times projected in two different projection directions. හරි. එන වෙලාවක් ගියා මේ ගානට හොඳ ගානක්. Right. Try the second question. The second question means second question in the exercise 2, sixth question in the tube. Try that question quickly. Try the question. Okay. Now listen. Question number 6. A particle is projected from a point on the horizontal ground with an initial velocity u equals to root 2 gr. Particle is projected from a point on the horizontal ground with an initial velocity u equals to 2g root 2g. So initial velocity we don't know at what angle, but initial velocity is u, which is equals to square root of 2g square root of 2 times g times capital R. The R is the horizontal range of the projection. Okay. At an alpha angle, at an alpha angle, projected at an alpha angle. Good. Ikram, the lunch is going. Right, Harne? Right. R is the horizontal range of the projectile. Show that the angle between possible projection directions is pi over 3. So they are saying this is the projectile. Okay. This is the range. So they are saying to get the same horizontal range, there are two possible projection directions. There are two possible projection directions, and they are asking us to find the angle between those two possible projection directions. Right? So that's the question. So we will consider the complete projectile. So let's say this starts at t equals to 0. I will take the t equals to capital T. Projectile ends at t equals to capital T. In this direction, let's apply s equals to ut plus half at square. S is capital R. U means initial velocity. U first alpha. Later on, we can substitute for u from this plus 0. We don't have any value here. So R equals to, sorry, U equals alpha capital T. R equals to U is square root of 2 times G times capital R plus alpha capital T. Do a cross multiplication subject capital T. We get T equals to, T is the only unknown value. All the other values are given in data. So this one will be R divided by root 2 times root G. G is the gravitational acceleration times root R. I'm writing this 2gr roots separately over times cos alpha. Okay, so this one will give us T equals to R over 2g square root of it over 1 over cos alpha or a sec alpha. We'll take it as first equation. So how did I simplify? Root R and R cancelling out, square root of R, square root of R, square root of the square root of G, all of them I can put under one square root. 1 over cos alpha, I'm writing it separately. I will take it as first equation. Right? All right. Next, what we can do? Horizontal done and the vertical done. I put the equation to the horizontal direction, I put the equation to vertical direction. To the vertical displacement u s equals to ut plus half at squared. S is going to be 0. U is going to be u sine alpha minus half sine alpha t minus half gt squared. 0 equals to u is square root of 2gr times sine alpha times what is t puta? Sorry, t equals to capital T. No? I substitute that capital T. I am taking t equals to capital T time. So capital T, we found that it's equals to square root of r over 2g times 1 over cos alpha, sorry, minus half g t square, minus half g t square. Do the simplifications carefully. Can you see? Square root of 2g here, square root of 2g in the denominator. I can cancel them off. Square root of r and square root of r is going to give you just r. Right? Sine alpha divided by cos alpha is tan alpha. Okay? Then t squared, not t squared, I can substitute. No, I forgot. T squared means this one square root will be removed. You will get, here see the t squared means this one square root will be removed. So you will get r over 2g, r over 2g multiplied by 1 over cos square alpha. So we get here 2g and 2g, root 2g and root 2g cancelling out. Root r times root r is r. Sine alpha divided by cos alpha is tan alpha. Minus, here's the method g and g cancelling out. So we get 1 over 4, 1 over cos squared alpha, which is 1 over sec square, 1 over 4, we can r over 4 sec squared alpha. That's a simplification. Okay. 2 into 2, 4, 1 over 4, r over 4. 1 over cos squared alpha, sec squared alpha. Okay. R is the horizontal range. So divide both sides by r. So you will get 0 equals to tan alpha minus sec squared alpha over 4. Multiply both sides by 4 and see. What do we get? I divided both sides by r. R is not equals to 0. It's a horizontal. We get 0 equals to 4 tan alpha minus what is sec squared alpha? 1 plus tan squared alpha. So simply remove the brackets and simplify. We get 0 equals to 4 tan alpha minus 1 minus tan squared alpha. Let's take all of them to this side and make them positive. Tan squared alpha minus 4 tan alpha plus 1 equals to 0. Previously, we didn't have to simplify the quadratic equation of tan because we just wanted to mention that there are two possible directions are there. We just had to say. Here, they wanted us to say that the possible direction between the two possible, angle between the two possible projections is 5 over 3. They wanted us to prove. If they wanted us to prove that, then we will have to solve this one. We can easily solve it by completing the square. What do you mean? Put a bracket, put a square. Forget about the square, right? Tan alpha. We have done, we are starting quadratics with the completing the square. Coefficient of this is tan alpha, okay? Coefficient of this one divided by 2 minus 2. Always minus square of this 4 plus 1 equals to 0. So we get tan alpha minus 2 complete square is equals to 2. Equals to, sorry, root 2 3. Minus 4 plus 1 is minus 3. Take it as a plus 3. I need more space to simplify. I think I'll do the simplifications here. I'll do it here. Let's take the square root of both sides. We get, when you take the square root of both sides, we have to consider the absolute value. Tan alpha minus 2 is equal to absolute value of square root of 3. Or else, method square root of 3 tiala, consider the absolute value here. It's better. It's better. When you are taking the square root, don't write plus or minus kila podium and we can't put plus or minus directly. We have to consider the absolute value. When we are removing absolute value, then we can say plus tan alpha minus 2 is equals to root 3, or tan minus tan alpha plus 2 is equals to root 3. Modulus, when you are removing the modulus, we can consider the positive and the negative possibilities. Correct? This is minus. So this one will give you tan alpha is equals to root 3 plus 2, or as 2 plus root 3, comma, tan alpha is equals to root 3 minus 2. Square root of 3 minus 2. I don't have enough space to simplify. Until this point, finish, will you? Finish until this point quickly. So we have obviously two values for alpha. Two possible values for alpha, which means we have two possible directions of projection. So they are asking what's the angle between those two. Obviously, this is going to be bigger, no? So this angle minus this angle, whatever the angle you get from here, that one minus this one must be equals to what? Pi over 3. Right. First, we'll finish this until this point. Okay. Right. I'll erase this part. So what do we get? Alpha is equals to tan inverse 2 plus square root of 3, and alpha equals to tan inverse root 3 minus 2. Omega k. Right. Nothing can do. These are the two possible directions. We have to go that the angle between these two is what? Pi over 3, 60 degrees kilo program. Give it a try. Give it a try. Yeah. Ah, yeah, that's minus tan alpha, no? Sorry. Sorry, here I made a mistake. This is minus tan alpha. This is minus tan alpha, so this is going to be 2 minus root 3, no? 2 minus square root of 3. Okay. मेहमान करो मुझको कैसे? Okay, yeah, alpha equals to tan inverse. We'll do like that. We have 2 plus root 3. And we have another answer, a possible answer for 10, tan inverse 2 minus root 3. I made a mistake here. This is minus tan alpha. So this is minus tan alpha. So minus tan alpha is root 3 or root 3 minus 2. So tan alpha is equal to 2 minus root 3. So we have to show that the difference between these two angles is 5 over 6, no? So let's say tan inverse 2 plus square root of 3 minus tan inverse 2 minus square root of 3. This is what we have to consider. Now, what is the hang in there? Listen. If we do like this, methodology, what case we can actually do that by taking this, what do you call? This one as some angle, this one as some angle. Let me tell you this one. At the maker, this is the easiest way that students can go. But that doesn't mean this is the 100% accurate method. What's the correct method? To solve this question, the most suitable method is going with the general solution. You create an equation and you go with the general solution. General solution part, I didn't do it here. But developing the general solution for tan, compared to that, developing general solution for sine or cos is easy in this question. So instead of simplifying until this tan format, we can stop in somewhere in the middle and we can develop a general solution from that point. But I didn't do that in this. Okay. So I give you as a homework, retry to do this question again using general solutions. I'll be putting or I'll be discussing the same question in our next class before we commence the other parts. General solution again, that's the most accurate way. That's the most accurate way. Right. And that's easy also. So let's take this one as gamma and this one as delta. So we get tan gamma. This is what we want. So this is delta. Right. So we know tan gamma is equals to 2 plus root 3. Tan delta is equals to 2 minus square root of 3. So we need gamma minus delta. So calculate the tan value of it, substitute the values and simplify. You should get pi over 3. I'm not going to simplify. Okay, make a homework. Homework network. We'll do that in the class because you are not going to do it as homework. Right? So consider gamma minus delta and consider the tan value of it and simplify. You will get the answer. Remember, give it a try and then I will discuss with the other method. Do you have a pen? Any pen? You are writing with this one? Right. Okay, how to solve from this? Here, see. Here, see, yeah. So I'm going to consider tan gamma minus delta. Now this is an inverse function simplification. No? We did inverse function make a baradine. Compared to this one, I prefer the general solution method, which I didn't do here. I'm giving that one as a homework for you. Make a hurry. Okay. We didn't do any logical errors in this. So tan gamma minus delta, I'm considering. Listen carefully. What's the expansion of this? Tan gamma minus tan delta divided by 1 plus tan gamma tan delta. So we get this equals to tan gamma is what to the 2 plus root 3 minus tan delta is 2 minus root 3. Okay. Divided by 1 plus 2 plus root 3 times 2 minus root 3. What is this? Remove the brackets and see minus 2 is cancelling off. Plus 2 square root of 3 divided by 1 plus. What is this? 2 plus root 3, 2 minus root 3. What the mean? Difference of 2 squares. 2 square minus root 3 square, which is 4 minus 3. So we have 1 plus 1. Right? We have 1 plus 1. So we have tan gamma minus delta is equals to 1 plus 1. Tan gamma minus delta is equals to 2 root 3 divided by 2, 2 and 2 cancelling out root 3. So gamma minus delta is equals to what to the tan inverse square root of 3. What is square root of 3? Tan inverse value? Pi over 3, 60 degrees. So gamma minus delta is equals to pi over 3. So therefore difference between, so therefore angle between possible projections is pi over 3. That's what they wanted us to show. Pi over 3. This is not the only way. So do you guys need a break before we move on? 7th and 8th questions, do them as a homework. We directly start the past with this question. Do you guys need a break? Online? Do you need a break? No. Yes or no? Yes sir, I need a break. No sir, we don't need a break. We can do what. Any response, please? I need individual responses. No break means continuously we can go till 3. Anyone? Do you need a break? Or shall we continue? Respond. I didn't get any response from anyone. I have one response at least. To continue. What about the others? Okay, no respond. Okay then, good. So since you guys don't want a break, good. Question number 7 and 8, do them as homework. Question number 8 is actually 2017 essay paper question. Do exercise 3 past papers. Start from 2023. Do 2023, 2022, those two past paper questions quickly. I'll give you 5 to 6 minutes. But sorry about it. Right. So the question is, a particle is projected from a point capital A at distance about a horizontal flow at an angle theta, where theta is an acute angle. So how they have mentioned theta is greater than 0 but less than 90. Okay. Right. Right. Particle is projected according to the given figure. You see, particle is somewhere here, which is simple A above the horizontal ground. Simple A above the horizontal ground, and to the horizontal at a theta angle with u initial velocity they project a particle. Okay, and u is equals to 3 times GA over 2 square root of it. Right? So this goes like this, and it falls like this. So until this point to this point is the projectile motion, and from here it's freely falls under the gravitation. Okay. So right? It just clears the vertical wall. It just clears the vertical wall. Now here see, yeah, this is a vertical wall which is away from, which is 3A units away from this. Just clears. Now the verb just clears means what? Learn the terms. Just clears means it's not going to go very up from the word. It's not going to touch the word. It's going to like just touching but not touching the word. Okay. So very tiny space. It's almost touching but not touching what is saying. Just clears the word, which means if this is A, this height is given 9A over 2. 9A over 2. So if this is A theta, this is going to be what? 5A over 2. This is 4A over 4 as A. So only 9A over 2. Which means if you consider only the projectile motion, okay, let's consider this point as capital P for reference. Let's consider this point as capital P for reference. When this particle goes, it just clears the wall means it's going to just go from here. For the projectile motion from A to P, vertical displacement is 5 over 4. For the projectile motion, the vertical displacement is 5 over 4. Right. That's the main idea you have to do. The horizontal displacement is same 3. Right. Now what they say, show that theta equals to tan inverse 3 over 2. They want us to show that theta equals to this and this scale. First of all, let's take the horizontal velocity component, which is u cos theta. This is u sin theta. For the horizontal displacement, I'm applying SC equals to ut plus half AT squared. S is 3A. U is u cos theta. This part becomes 0. Why? No acceleration. So 3A divided by 3A. This equals to what is u? 3 times square root of GA divided by 2 times cos theta. So from here, cos theta we can subject it. We have 3 and 3 cancelling out. So you get this is equals to A times square root of 2 divided by square root of G times square root of A. We get something like this. No? I'm doing the cross multiplication. Square root of G, square root of A, square root of 2 goes up. A and the square root of A cancelling out, this becomes square root of A. So 2A over G, here we get cos theta is equal to 2A over G square root of 2. Sorry, I forgot T. T 1 over cos theta. I forgot T, okay, medan T kamaduna. Okay, I'm taking the time taken here as T. Sorry, sorry. I'll subject T. So let's take it as first equation. And to the vertical displacement, we'll apply S equals to UT plus half AT squared. Listen. This one is the vertical displacement of the projectile is 5A over 4. What is U? U sine theta minus half G. U sine theta T minus half G T squared. Now listen, now I can substitute the T value here and U value also. 5A over 4 is equals to, what is U to the 3 times GA over 2 square root of it multiplied by sine theta. This is 3, this is U, sine theta, what is T? T is this, square root of 2A over G times 1 over cos theta minus half G times, what is T squared? T squared 2A over G times 1 over cos squared theta. Do the simplifications carefully. Here's here. Root G and root G cancelling out. Root 2 and root 2 cancelling out. Root A multiplied by root A is A. You get 5A over 4 is equal to 3A sine theta over cos theta or else tan theta minus 2 cancelling out, G and G cancelling out. A over cos square theta, which is A times sec squared theta. We can clearly see that A is a common factor from both sides. A and A we can cancel. Multiply the entire equation by 4, you will get 5 is equals to 12 tan theta minus 4 times sec square theta is equal to 1 plus tan square theta. We get a quadratic equation in terms of tan. Solve it quickly. Remember, finish it. You got it. Very good. Okay. So we get 5 equals to 12 tan theta minus 4 tan square theta. So subject 4 tan subject means take all the terms here. 4 not subject. Take all the terms to one side. Here get minus 12 tan theta plus 1 equals to 0. Oh my God, minus 4, no, sorry, plus 9. So this one we can simplify like this. Take 4 as a common factor outside. We get tan square theta minus 3 tan theta plus 9 over 4 equals to 0. Divide both sides by 4 and then complete the square. You get tan theta minus 3 over 2 complete square minus 9 over 4 plus 9 over 4 equals to 0. Which means tan theta minus 3 over 2 equals to 0. tan theta minus 3 over 2 square is 0, which means the square root is going to be equal to 0 only. So you get theta equals to tan inverse 3 over 2. Where did you make the mistake? Mistake, and you got two answers, right? One is minus, one is plus. Is that so? Yeah. Same answer again. Same answer repeated twice. You can consider only one answer. Okay. So this is how the question goes. This is a 25 marks question now. Full 25 marks question. So see how easy it is. Was it hard? Online students. Compared to the model questions, it was not hard, but this one, tell me, did you get the answers? Aida, Aisha, Ruska, Kashiban? Finished? Done? What the answer? Same application was there. Reply quickly. If you have any doubts, ask me now itself. Okay, right. I'm going to do 2022 question. Right, we'll do 2022 question now. They're saying capital A and capital B are 2 points on a horizontal ground such that AB equals to simple A. I'll erase this. Capital A and capital B are 2 points on the horizontal ground such that AB equals to simple A. It's given like this. AB distance is simple A meters or units, like that. Two particles, capital P and capital Q. Capital P is pointed at capital A point, capital Q is P point. Okay. Projected from the points A and D respectively at the same instant. Both of them projected when P equals to 0. Okay, at the same instant, same time, both of them projected, right? At the same instant, and in the vertical plane that contains line B, such that they collide with each other after the time capital T, after time capital T, which means this one projected at an angle pi over 6. Okay, this one projected at an angle pi over 6, 30 degrees angle, and this one is projected at an angle pi over 3, 60 degrees. Okay, two different angles. But however, this one path is like this one's path is like this. Both of them meet at some point on the space when the time is equal to capital T, which means same time both of them projected in from two different places at two different angles. At the same time they projected, they will be meeting at some point at the same time. Okay, when T equals to T value, they both meet. Now what they say, The initial velocities of P and Q is given. P is 3GA root of it. Initial velocity of this one is U. So they are saying, show that U equals to root G and find T in terms of T in terms of A and G. What is that? A very simple one. A very simple one. They want us to show that U equals to square root of GA. What is that? Think. The heights reached by both the particles are equal, right? The heights reached by both the particles are equal. So let's say this height is h. When t equals to t, the height reached by both the particles are same. So for particle t, if I apply s equals to ut plus half at squared, let's take it as h equals to root 3GA sine theta, sine pi over 6. T is capital T, no? Capital T minus half T squared. For Q, if I apply S equals to UT plus half G T squared, what is S? The same height. UT, what is U? U sine 60. U sine pi over 3. Okay, U sine pi over 3, capital T minus half G capital T squared. After that, these two are same for both the particles. Why? Both of them meet at the same point on the space. Means same this vertical displacement must be at the two different vertical displacements, then they can't meet. Right? So 1 equals to 2. We can write like this. Square root of 3GA multiplied by sine theta is half times capital T minus half GT squared is equals to U times sine 60 is equal to square root of 3 over 2 times T minus half G capital T squared. Yes, is that? Minus half GT square on both sides. So if you take this part to the other side, becomes it will be cancelling out. And then after that, I can see T is a common factor, so T is also cancelling out. Then after that, we can see 2 is also in both sides of the division, so this one also cancelling. Don't think that I'm dividing this 2 and this 2 in the same step. I'm doing 3 steps at once. Right? This is 2, this is T, this 2, this is T. In the next step, square root of 3GA times half T is equal to U root 3 over 2 T on the numerator. So this is a common value in this side, half and T. So root 3 and root 3 also we can cancel. So we get square root of GA remaining on this side. Only U remaining on the other side. U equals to square root of GA. This is what they wanted us to prove. It's right. Look what I done. Right? And find capital T in terms of A and G. Now we know the U value. Since we know the U value, we can calculate the U in there. Take the P particle and apply S equals to UT plus half AT square horizontally. What is the horizontal displacement? A. Sorry. we can do, no? Listen, by considering the entire motion, you can do something like this. You see, you can calculate this distance, right? You can calculate this distance and then apply the same formula horizontally for this particle, and you can calculate this point and this point formula for them. You can calculate the value of T in terms of A and G. Currently, I'll give a couple of minutes, like 1 minute again. You can now calculate this distance by applying S equals to ut plus half a square in this direction to this q particle. You can do it. Give it a try. Right. So let's say this distance is x. For the particle q, I'm applying horizontally in this direction. S equals to ut plus half a t square. So s equals to x. That's what I'm going to get here in terms of capital T. So this is equals to u. U means the initial velocity, initial horizontal velocity. U cos 60. Q is root g a, no? Cos 60 is half, directly substitute. Times capital T, this one becomes 0. So we get x equals to root g a over 2 times t. Okay, let's take it as the equation. So I'm going to apply for p particle in this direction. S equals to ut plus half a t square. I'm applying for capital T and then the u bar b particle goes from here to here plus this one, no? Area of x. So this displacement is going to be x plus x. What is this x put up? We'll substitute it in the next step. This is equals to, what is u? U is going to be this one, no? I'm applying for p particle, no? So this one, root 3 GA cos 30. Square root of 3 GA cos 30 is root 3 over 2 times capital T. That's it. Because this part is going to be 0. Now we know x value, what is it? Root GA over 2. So from 3, I'm going to substitute. So we get a plus square root of GA over 2 is equals to root 3 times root 3 is 3. 3 over 2 square root of GA times capital T. Here I forgot. Right. So take this part to the other side. So you get A equals to 3 times square root of GA, 3 square root of 3 square root of GA over 2 times T minus minus square root of GA over 2 times T. If you simplify this one, take a common denominator and simplify and see. 3 minus 1 is 2. You get 2 root GA times T divided by 2, which means root GA times capital T. Give me a minute. Guys, give me a minute. Finish the simplification. I'll quickly get back to you. Sorry, my parents are not at home, so I had to buy food for my siblings. So order karke aage. So A equals to, this becomes 2 root GA times T divided by 2 in 2 and 2 cancelling out, you get root GA T. Divide both sides by square root of GA, you get T equals to A over square root of GA, which gives you A and root A cancelling. If you simplify, you get A over G square root of A. So they wanted us to find the value of T in terms of simple A and simple G. So this is the answer you get. Alright? Okay. Alright. We'll do one more question and then we'll wind up the session for the day. Right. Try 2021 question quickly. Try 2021 question. I'll give you a couple of minutes, then I'll discuss. How good? How about 2021 question? A particle is projected from a point capital O at a vertical distance above a horizontal ground with initial velocity root GA. Projectiles is one of the easiest lessons you have just to manipulate the equations and do the simplification sharply. Don't make errors in simplification. Simplifications horizontal. And you are our babies. We can't show you how to simplify roots. So write every step of the simplification doing you must have some sort of a idea. So here's here. So at a vertical course, on a vertical course from capital A point, from simple A height, from capital A point, they project a particle at an angle alpha to the horizontal ground with GA initial velocity. Okay, rho GA initial velocity. So alpha is an acute angle. So it goes on a projectile motion and then hits the ground like this. So this distance is also given as simple A. Simple A. The particle strikes the ground at a horizontal distance from a distance A from O, so that alpha is equal to 1 plus root 2. Alpha is equal to 1 plus square root of 2. It's a very easy part. I'll give you one more minute. Think. A very simple one. You should be wise. මෙතන පුතා not just the projectile motion, you have to consider the entire motion. Projectile plus freely falling under gravity. Okay, projectile motion is also freely under gravity, no? So dekama total motion you have to compare and take. Right. Now stop working and listen. No? Stop working and listen. Listen carefully. For the entire motion, let's name this point as, if you want, you can name it anyway. I will name this point as P. From O to P, complete motion I am considering. If I apply S equals to UT plus half AT squared, so T equals to 0 with throw, it falls hits the horizontal ground when T equals to simple T. Assume like this. Assume like this. So what is the horizontal original point to this point? Students, any answer? What is the horizontal displacement of the particle from this point to this point, if you consider from this point to this point? Right? Horizontally, how long it has traveled? The message in the chat box or unmute someone. Quickly. It should be correct. Physical students giving me correct answers. What about online? But okay, nothing bowling one. O-level day. Horizontal displacement. From this point to this point, horizontally travel distance. Simple A distance. Chat box whatever you can unmute and know. Simple A distance. For the entire motion, initial velocity is given. I'm discussing initial horizontal velocity. It's going to be this rho GA cos alpha. Root GA cos alpha. This side we don't have any acceleration, so this part becomes 0. From here I can subject T, we get A over square root of GA times cos alpha. So I can rewrite it. From here I rewrite it T equals to A over T square root of it times 1 over cos alpha. This is my first equation. And then O to P for the entire motion I will apply S equals to UT plus half AT squared. Then Aida, Aisha, Ikram, Prasivan. What's the vertical displacement if I am applying for the entire motion? If I am applying, what is the vertical displacement of the body? Minus A. It should be minus A. If you can't tell answers for this, physics right. Minus A. This is equals to, how did minus A came? Mechanism coming from this point to this point, and then whatever the displacement which has taken here, it's completely finished. And then it's turning back and coming down. I'm applying this one. A distance is going down, minus A. What is U? Initial vertical display velocity. Root GA sine alpha. T I will substitute from 1. What is T? A over G square root of it That's 1 over cos alpha minus half a, but is t. T is the this one, that one square we have. So here 2 over g times 1 over cos square alpha we get. So do the possible simplifications quickly. Root g and root g cancelling out. We get minus a, I write here, minus a equals to root a times root a is a, sin alpha divided by cos alpha is tan alpha, minus a into a squared over 2g sec squared alpha. Sorry, sorry. Half a remaining g, acceleration is g, no? Times t square. T square is this. A over g 1 over cos squared alpha. My substitution is wrong. This g and g cancelling out, so this is not what we get. We get minus a over minus a sec squared alpha over 2 omega n. A sec squared alpha 1 over cos squared alpha sec squared alpha divided by 2. So a is a common value on both sides, so I can remove it and multiply both sides by 2. So we get minus 2 is equals to 2 times tan alpha minus sec squared alpha is equals to 1 plus tan squared alpha. Remove the brackets. Minus 2 is equals to 2 tan alpha minus 1 minus tan squared alpha. Take all the terms to this side, you get tan squared alpha minus 2 tan alpha minus 2 plus 1 is equals to 0. So this one is tan alpha minus 1 complete square equals to 0. What they wanted us to prove finally? 1 plus root 2. I may have done a mistake somewhere in simplifications. Simplifications will know. Or when I'm substituting, somewhere did I make a mistake? Yeah, I have done a mistake somewhere. I couldn't find it. Someone can point out to me. I made a mistake in simplifications. Yeah, brother. I couldn't see any error. Where did I make the mistake? Tan squared alpha minus 2 tan alpha minus 1 equals to 0. Make it hurry. Okay, I'm correct. Okay. So let's complete the square of this one. You get tan alpha minus 1 complete by minus 1 minus 1. Okay, I made a mistake by writing it as complete square. Okay, when I'm writing this one, the next step I wrote it as a complete square. This should be +1 in order to write like that. That's a mistake I made. Otherwise, no simplification. Take this -2 to the other side, it becomes +2. So tan alpha -1 complete square is equal to +2. From this one, we get modulus of tan alpha, or as tan alpha -1 is equal to modulus of square root of 2. Okay. So let's take 1 to the other side. Tan alpha is equal to modulus of 2, modulus of root 2. Alpha is less than, alpha is greater than 0 and less than 90 degrees. Obviously, it's an acute angle. Acute angle values can be what? Positive only. Positive only. This modulus I can simply remove it. If the modulus, if this root 2 becomes negative, what happens? Minus root 2 plus 1 is a negative answer. Negative answer is not possible for acute angle tan ratio, because acute angle tan ratio is obviously possible because it's in the first quadrant. If this is an acute angle, it's given, then obviously alpha tan alpha must be equal to positive root 2 plus. Therefore, I can say alpha equals to tan inverse square root of 2 plus 1, or is 1 plus square root 2. Decision making and writing this step is super necessary. Those are very important. Right. Online students, quickly confirm me through the chat box. Are you guys clear with the things we discussed so far? Everything? Is the chat box is disabled? Chat box is not visible to you guys because I'm not receiving any responses from you. That's why. All clear, understood, fine. Right. So these things are not enough. You will have to continuously work. But the lesson wise from my end, the theory part and the required calculations and required identifications done. Then this Thursday class I will finishing the course. I was supposed to finish last time, but participation was not good. That's why I will finish. I will finishing offline progress, and then Sunday morning class I will do calculations from next Sunday. I will starting relative motion lessons. So I will start with relative velocity. Sorry, relative velocity equilibrium. I will be discussing equilibrium, and after that friction, and then we move on to relative motion. Okay, equilibrium and friction we have to discuss. July 2nd week, I will be moving on to relative motion. Okay, so then today's session, that's it. We will wind up for the day. All good to the I need individual responses. All good. Clear? Drop a comment in the chat box quickly regarding the session today. Comment yes sir, clear sir, neighbor. What you care, just put as a comment. Comment doesn't mean yes sir, clear sir, like and sergeant can salute. Fine. You have a doubt? Huh? Yeah. Okay. We'll discuss after the class. Okay. Right. Okay. Then if you have nothing to do, then you can leave. You meet on next session Thursday, day after tomorrow, with another applied lesson. You all can leave. Good luck, guys.